shortly about to begin. Thank you so much for being here right on time. Speaker is on the way thanks to Bangalore traffic, but he should be here in the next 5-10 minutes. Before we begin, I'd like to seek your cooperation in just switching off your phones or putting them in silent mode. Additionally, we have some seats here as well, so please occupy this side as well. And yeah, we'll begin shortly. Thank you so much for understanding. Should I start?
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity, and optimizing every step of the process.
AI Run. It really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
With clearer requirements, help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained GenAI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product.
Okay, good morning, ladies and gentlemen, and welcome to the second day of the 4th edition of Data Engineering Summit 2025, India's first and only conference dedicated to the emerging field of data engineering, proudly organized by AIM Media House. I hope you all had an unforgettable day one, packed with really enlightening sessions, valuable insights, and incredible networking opportunities. DES 2025 is your gateway to connecting with top data engineers who will deep dive into the latest trends and best practices in the industry. Today as well promises to be another exhilarating day with a dynamic lineup of sessions and activities that are designed to inspire and inform. Before we begin, I would like to start by thanking our sponsors, without whom this would not be possible. This year's DES 2025 is powered by Genpact, leading global professional services firm, in association with Mathco, Snowflake, and Tiger Analytics. Our platinum sponsors, EPAM, IceDQ, and Starburst, and our gold sponsors, ClickHouse, Sigmoid, Target, and Tredence. Silver sponsors, CData. Exhibit sponsors, Carrier, Melissa, Startree, and Edo. Before we move on to our session, we have some quick announcements for you all. I hope you all enjoyed the exhibition stall that is right outside this hall. I'm sure you all won a lot of goodies, which we saw a lot of you carrying. The same is out there today as well. And please do not miss on spending some time at the AIM stall booth. If you loved being here at DES, you would love to be there with us for Cypher, which is one of India's biggest conference that is happening in September 17th to 19th. And so we have some exciting games that are lined up for you in the stall, for which you can earn some really amazing coupons and discount. So do not miss out on that. And we have our AIM magazine copies that are out too. So please do get your copies today as well. Great. Are we ready for day 2 today? Okay, perfect. Before we begin, whose first DES is this? Oh, fair lot of you. And is this the first conference that you all are attending as well of AIM? Yeah, okay, fair bit of it. For the people who have been here before and the AIM conference, which is your favorite? If I can have maybe some answers shoot out. Which is your most favorite conference that we host? So I heard some Cypher. Anyone else? Cypher only. Okay, perfect. Okay, great. So we have, talking about Cypher, we are hosting one of the biggest ones this year. It's more around an expo that we are doing. It's for 3 days. And you all can know some more at the AIM stall. So do visit the stall and know more. Great. We should be able to start in the next few minutes. Till then, can we have the DES video played out, please?
From cave walls to phone calls, we've always wanted one thing: to connect. Over time, how we connect has changed. It got faster, smarter, and bigger. Now it's not just people talking to each other. It's machines, apps, systems, all talking through data. And at the heart of it all, data engineers, building the roads that keep this new world running. Data and AI are helping us live better, work faster, and solve big problems. This is just the beginning. Welcome to DES 2025.
Perfect. So kicking off day 2, we have building scalable data engineering pipelines for responsible AI application using personalized data in InsurTech. This session will explore the critical role of scalable and efficient data engineering pipelines in the age of responsible AI, especially within data-sensitive industries like InsurTech. Leading this session, today we have with us our first speaker, Harish Ramarao, Senior Vice President of Engineering at ACO Technologies. With deep experience in building data-intensive systems for the InsurTech sector, Harish is uniquely positioned to speak on the intersection of AI responsibility and data architecture. Ladies and gentlemen, can we have a huge round of applause for our first speaker of day 2 of DES, Harish Ramarao.
Can you hear me? Yeah, thank you. Good morning. So, feels more like a stand-up setup, no? Doesn't feel like a whatever. I was wondering what to do right now. Anyway, welcome. Yeah, it's day 2. So my name is Harish, and I lead engineering at ACO. And yeah, today the most relevant topic for discussion, of course, is AI and responsible AI. That is how we in InsurTech look at it, right? I mean, AI means a lot to many people. So let's start. And I know there's a clicker here. Okay, we can skip this. You know my name already, right? And I'm running this because I have my data point somewhere, right? So we'll begin with what is responsible AI, right? And I put it in this fashion. Responsible AI essentially means that using data ethically. So far, I mean, in my previous lab before ACO, of course, with Flipkart, and back then we had India's largest data lake, right? Back then in 2014-15. We were generating roughly about 30, 40 gigabytes of data, in about half an hour. Every data, click, stream, the way you hold your phone, your swipes, your clicks, your left, rights, etc. So one is you collect enormous amount of data. The 3 V's as we call it, right? Velocity, variety, right? So how to use data ethically is what forms the foundation of responsible AI. Why we'll come to it in maybe a couple of slides more. What do you mean by ethically handling data, right? Ethical handling means that you securely handle personal data. The key point is being throughout its life cycle. So it's not just at the point of collection. It's not that you safely, securely somehow get it, but then you should be able to handle it both through ingestion, handle it at storage, handle it during intra-system transmissions, handle it when you hand it over to a model, right? Of course, when you do inference on top of it, then when you send it back to the customer, of course, it could be sending it via a chat mode, sending it via some other media. It could be bulk, for example, like in insurance, for example. We do a lot of bulk updates to customers saying, hey, here is where benefits are, etc. Right? And then, how do we achieve that? Critically, clearly, you first number one, you need to know and you need to collect only what you need, right? Now I don't know if you have ever given your phone number to somebody in some metro store, shoe store, somewhere in some mall. The next 20 days, you're going to get calls from random people, random companies you've never heard of, right? Because they're collecting what they don't need, right? And they don't collect when they need it. So the first step of responsible AI as an organization, corporate, is only to collect what you need, right? I mean, we're all data hungry. We're also data hungry. But it doesn't mean that you collect anything and everything about the user, right? Then there's a lot of it junk data. Just because storage is cheaper right now doesn't mean that you collect everything. Second thing is only when you need it, right? So even before you are able to see a code, they'll ask everything. Where do you stay? What is your phone number? How many people are in a house? Blah. I mean, you don't need it at that point in time, right? So being responsible means also being responsible on what to collect and when to collect. Yeah. And then the most important thing right now in the world of AI is ensuring fairness and transparency and accountability. We'll get into this in a little more detail. That's what my session is all about. And of course, at the bedrock of this, you have to implement data privacy regulations to ensure that you're always protecting the user, not you. It's not about if my data gets leaked, what will happen to me? No, that is secondary. Primary, as an organization, as a corporate, as a technology guy, as an architect, as an engineer, you have to think about how do I protect users always first. Yeah, everything else comes in later. Right, so what data do we collect? Now I was just talking about being responsible and collecting as little as possible, but here goes. Is this not all what we generally collect, right? We collect everything, right? We collect customer data, non-personal. We collect, like for example, where do you stay? We collect streaming data, for example, right? How do you click? How many times you visited the website, right? What frequency did you visit the website? Did you scroll on the website? Did you look at the details page, etc., right? Device metadata, what phone is it? We have this seen very often. There is all these things going around on the internet, that Uber is expensive on iPhone, it's cheaper on Android. You have all that, right, going around. Why? Because there is some device data, metadata. Is it an old phone, new phone? Does this user change phones very frequently? Bahut paisa hai kya iske paas? Whatever, right? You're trying to collect all that, isn't it? Then environmental context data. For example, what is the weather today? It matters especially in insurance when you're doing, for example, insuring buildings and houses, etc., right? Yeah, is it raining today? Suddenly has it become very hot? Have they cut down a lot of trees in that area, etc., right? Payment and purchase data, of course, you have to collect, you have to store it, because customers have paid you. You still try to collect what IP address was it paid from, when was it paid, etc., right? And then, of course, in insurance, let me take that use case. We collect data about the car. If you are buying health insurance, we collect data about your health. Of course, you collect, buying life insurance, you collect data about, you. Then there's government data from other agencies, right? What is your credit score? What is this? What is that, right? Then, of course, some proposal data. Who's in your family? What is your age? Are you healthy, not healthy? Then relationship data. How many people are in your family, right? And, of course, some PII data about you, right? So when you think about all this, just imagine the responsibility that comes with collecting all this data, right? Some data is publicly available, like environmental data, government data probably is publicly available. Some data is not very harmful, like your device data is okay. I know you have an iPhone, I know you have some sort of Samsung, it's okay, and it's not such a big deal. But more things like, for example, payment data, your proposal data, family data is very, very critical, right? You need to know how to safely, securely, responsibly handle it, right? So, yeah. Oh, I'm not moving it here. Right. I call this traditional simply because you have to understand how securely data was collected in the past. In the past, data was collected by somebody talking to you, right? Somebody is filling a proposal. A doctor is talking to you, try to get health data, not the doctor sitting in the garden, by the way. This is what best Ghibli could do. Anyway. And then people are collecting data, for example, via surveys, right? People are collecting data, for example, by talking to you. And so this environmental data collection, personal data collection, private data collection, etc. This is more, let's go back from there to what, how it looks like today. So I think a lot of you will connect to this particular slide, right? Where this is how we essentially collect data today, right? The most important thing to understand is not just collection of data, it is about enriching the data. That's what the enrichment layer inside is all about. What is enriching data? Enriching data is essentially connecting semantically two data points. I know this about you, I know that about you. How can I enrich that to understand more about you? People call it profile building, people call it something else. Profile building is a very specific term. It's only about the customer or the consumer. Enriching essentially means, can I, for example, connect day of time of usage with the device and understand whether this person is comfortable doing a certain activity sitting at home versus is the person comfortable doing a certain activity in the office or somewhere else, right? Is the person frequently on the metro? Is the person frequently, for example, again, way back in my e-commerce days, we knew that a lot of people between 6 and 8 are actually traveling when they are surfing the e-commerce website, meaning bus mein baitha hua hai, trying to look at what next to buy, right? So you're able to contextualize the data, and that's important, for example, when you do inference on top of it, right? Then, I think most of you already know this. Denormalizing the data becomes very critical before you send it to some AI engine, right? Why? The more context the AI system has, and I'm jumping the gun a little bit here, already introducing what we're trying to do, but the whole idea is to understand the more context the engine has, the better the inference is, right? For example, if you just tell the engine, here is the customer, here is the device, here is the date of time, here suggest, what should I tell the customer, for instance, versus saying, here is the customer, here is the device, here is the history of what this customer has told me, right? Here are all the other people probably, who need to be part of this particular context, right? Here is the external data for the particular customer, right? Here is the previous inferences for which, a certain output yielded better results. So when you contextualize all this, when you enrich the data, you bring it, all of them together in a very huge denormalized fashion, then better would be your results. Where does responsibility come into it? We'll come into it at a second, because this denormalization essentially means that you are sort of connecting secure data, non-secure data, sensitive data, non-sensitive data in a large denormalized input format, right? That's where you have to figure out how much to get, how to get, when to get, how much to store, whether it is ephemeral storage or whether it is long-time storage, right? And how little to tell the model so that everything doesn't go in, but how much to tell the model. Yeah. So that's about then we can look at different types, or let me say, what's all again very critically important is, let's take a look at this, right? An event pipeline that also, for example, is getting in asset data or family data, right? Event data is essentially saying, did you switch on the phone, right? Did you come to my site or app? Did you click on this? Did you swipe? Yeah, did you click on whatever? That's event data essentially, right? When you marry that with, let's say, the family data for the particular customer, what you are getting is you're getting multiple POVs, as we call it, point of view, yeah? Am I looking at the customer's conversion point of view? Am I looking at the customer's learning point of view? Like insurance, for example, some insurances, like health insurance, It's a long-term consideration product, meaning to say people don't, it's not like, it's not impulse you buy. It's not like you go to Flipkart, oh, this is looking nice, 50% discount, buy. Nobody does it in insurance, right? I mean, you don't wake up to say, aaj mere ko insurance kharidna hai. Nobody like wakes up to do that, right? It's a long consideration cycle. People come in, they take a look at your site, they go to somewhere else, they do comparison, they ask a friend, they ask, that universal chacha at the house who knows everything, right? They go there, they take enough amount of time, right? Maybe months. And later they come back and say, here is what I feel is good. In that period, you've engaged with the customer, you've generated a lot of content data, both personal, non-personal, semi-personal, public data, you've brought all of them together. You have to create a POV on top of it, right? For the next interaction with the customer, what is my point of view of asking that, right? That's where the data pipeline again comes into picture, of course, and then, you need to have the ability to process both structured and unstructured data. What is unstructured data? For example, I can say, hey, give me your last year policy from some other vendor. I'll tell you how I'm better or not better, or I'm a good at it or not. That's sort of semi-structured data, right? Because I don't know the structure of what you've bought before. I don't understand the terms and conditions. I don't know the benefits that are currently there, right? So we'll spend a little bit of time on this. And at the end of the session, I don't know how much time I have. Maybe we will pause a little bit, maybe take questions on this slide. We'll revisit this slide later if anybody has. Yeah, so what does this mean? This is a very typical inference system, right? I mean, a lot of you have built systems like this. The key point that I'm trying to drive here is the following. The most important part is, of course, you have a bidirectional communication channel set up, with sockets, right? Which means to say that if you are especially in a chat mode, interactive mode with the customer, you ask the customer to send you something, ask something, basically request, you hold the context, and then after that, you have to send it back to the channel, in which the customer is talking to you, right? And sockets essentially do that, which means to say it is not a fire and forget sort of a mechanism. It is where you're in session with the customer. So we call each socket session, for example, as one context. And of course, there is a system that you'll have to build to manage that particular context, right? So what does this guy do? I just call it the context manager. You can call it whatever you want. While all engineers don't aspire to be managers, we love to use the word manager in every system, right? This manager, that manager. Nobody knows what the system does, but we name everything as a manager. Just to ensure that it is a wrapper, it is an aggregation technically, that does something. Yeah? More than one responsibility, let me put it that way, right? A multi-responsibility component is always called a manager, technically, right? So a context manager just says, hey, I am now connected to the customer, and I'm now maintaining the conversation context, right? What is critical is to, for example, have a conversation cache. That is, I'm just calling it a cache. Essentially, it's both ephemeral and non-ephemeral storage. What it means is, how do I know what you have spoken to me before? I think 4 or 5 days ago, Sam Altman was talking about that ChatGPT will remember everything about your lifetime, if you know the latest news. What he's trying to say is, my next communication to you will be based on everything I know about you. So last year, at the same time, if you asked me a question, can I go to Thailand? The next year, if you ask me a question, and if you're like trying to find out if Bali is good, I have the context ki same time last year, bachon ke chutti ke time pe you asked me the question about Thailand. So that entire context building, of course, it's different at that scale. But in your applications, it is sort of very beneficial if you have the conversation cache. Now, this is non-personal and semi-personal data here. Meaning to say, customer in the case of insurance might be asking, hey, my son or daughter, now suddenly became an adult, right, from 18 to 19. And let's say the policy does cover only kids. So what happens to this person? The customer is asking you, right, either on the text, chat, doesn't matter. The medium doesn't matter. So that context last year, so next year when you come back and say renew your policy, you need to have somehow that context that, okay, this family is now looking different, right? So it's sort of semi-personal data. Semi-personal meaning it's not so critical, to hold that at the same level as PII data. But it's also important to have that particular context, right? So having a responsibility at the time of maintaining the conversation cache becomes critical. That's the point I'm trying to drive, yeah? Then you have a very typical agent system, which of course does 3-4 things that you guys are aware of. There's already a planning module, there's an intent module, right? There's a tool selector because any application worth its salt will have tools in it, right? Without the tool, what does the application do? Nothing. It is basically taking something and spitting out something else. The purpose of having this system is to ensure that certain things happen in the background, right? That the system is able to do something. And the do is usually your OLTP system, right? I mean, if I take, for example, payments, by the way, and I saw this Razorpay built a very nice MCP server. I don't know if you've seen the demo on YouTube, it's very nice. You can say, hey, make a payment on chat, and then I think it's on Sonnet, it goes and makes a payment, right? So effectively, if it doesn't do that payment, there's no point in having that entire application built, right? So you have your own tools that are able to essentially do something. Either they do something on the system of records, which is essentially CRUD services, usually REST, and of course, different SaaS clients, right? I mean, by SaaS, I mean anything that you have built yourself. Anything that is callable over an API, I'm just calling it SaaS at the moment, right? Then this is so far so good. Here, there's not much security that you have to include, except for the fact that your agent essentially knows what to call and is making secure calls across, right? I mean, we all assume that this is based on the Zero Trust API framework, that systems are able to talk with each other securely, etc. Only the data that has to be exposed is exposed, nothing else is done. The critical part comes where the RAG pipeline is getting built up. Today, of course, all of us build applications with RAG. Otherwise, it's very difficult to maintain that large context and, sort of tokenizing, embedding. The critical information here is the document sources. Let me put it the other way around. Your document sources are what you have to tokenize and keep, because there is no point in tokenizing your unique data, because that unique data doesn't really have that kind of embedding, right? I mean, why do you embed? You embed to ensure that you already have the distance, vector distance. So when you create the pipeline, send it to the LLM, it's able to do something, right? Your record and my record are very unique in the system, right? Every system, every record that is very unique, it doesn't help if you create embedding, because that embedding is extremely unique. Like me and my phone number are very closely connected, right? It's not like there are 10 phone numbers pointing to me, unless, I don't know, I'm like some very shady telemarketer, I'm using 25 phones, and all of that is in public data. That's not going to happen, right? So you need to create, or probably, at least I have seen this to be very useful, and hence, I'm putting it out here from my own experience. The embeddings are important where there's a lot of public information that you're putting in. For example, you're putting in data around how can I make a claim? It's public information, right? How does hospitalization work, for example, right? Hey, if I get hospitalized for a cataract, will the syringe cost be covered? Now, this is not specific to you or me, right? This is available everywhere else, right? This is, in my view, far more important. It is very beneficial, because the moment you take that, you put it in the embedding, then you take your personal data, connect it and send it to the context, very useful information comes out of it. That's where the responsibility of the AI comes into picture. You're not you really don't have to build a very secure RAG pipeline for public information or product information. What is product information? My product. It could be an insurance, it could be car. If you're selling a car, it could be your prospectus of the car. If you're selling something, a loan, it could be the details of the loan. It could be anything. You can sort of fill in the blanks with your own industry, your own product, your own company, and say, hey, what is publicly known about my company? Blah, right? That blah goes into your product information. That is not so important to be sort of managed very well. You don't need a lot of responsibility there, because it's anyway publicly available. Somebody goes on Perplexity and asks a question, probably it will do the same thing, it will give the same response, right? What is important is the document processing, vector embedding, building only on top of public data sources, and your agent is able to retrieve contextual, limited scope, obfuscated data. That is the critical piece. This is probably your own OLTP systems today, meaning your own systems, your company systems that have been running for 25, 30, 40 years. Could be an Oracle system, could be an SAP system, your homegrown system, could be your own e-commerce system, right? Could be your ordering, whatever. Because that has got a lot of personal information. It has got personal records of the customer. It has got a tokenization service example, for example, to tokenize what is only needed. At least in my view, the most important, is it coming up there? Okay. Because here the monitor is nice, I'm able to read it. I don't know if you can read it there. I'll read it out for you. So the arrow mark that goes from AI agent systems to data vaults, that arrow mark, the heading is called contextual, because it is contextual, meaning, what is contextual? Let me put it this way. By contextual, I mean, let's assume a conversational flow here, a chat flow here. In the conversational system, when the customer is asking a particular, let's call it a question at the moment, it's just a request. I know so many things about the customer, right? Do I need everything to answer this question? That's what is contextual, right? I may know everything about the customer. Do I need everything, for example, right? I mean, if let's say I'm doing e-commerce or in insurance is also okay. You say, I know that the customer has bought this and this. The customer's tiering is probably something. The customer's past checkout data is whatever. But the customer is asking me a question, for example, to say, hey, last time I bought shoes 9. Now this is a new brand. I don't know whether shoes size 9 will fit. What do you think? It's a fair question for the customer to ask, right? Because that is typically a use case for an AI. It's not a search use case. So then you have to go back and say, hey, all these models, all the previous history, shoes history. Now you don't need the waist size of the customer. It's not relevant to this particular conversation, right? So you only pick up that segment of data responsibly again, and then you say, hey, now what do I know about all the models of that particular company? How have other customers reviewed to say size 9 here, guys, is not size 9. This shoe is slightly tighter, so maybe buy one size more. You'll have that, right, regularly on the e-commerce website. So that information is public. So that is public information. You have the shoe size of the particular customer and the ask of the customer. Contextually, I will call it a segment at the moment. Contextually, you only pick up that segment, and then you connect that with the public embedding of what you already know, and then the agent sends it to the LLM system. That's what the diagram is trying to say. So your responsibility comes into A, only getting what is needed securely, which means to say that you don't say get everything. Yeah? api.something.com/customers, customer ID is equal to 123 get. You get like one dump of data, like some 10 GB of data or whatever, 5 MB of data. And then in that you loop through and figure out, oh, I need only this. But then what happens to the entire data it has gotten? You need to securely be able to keep, store. The agent has everything now, right? The reason why this is critical is if your agent is writing code to call a tool. If it's just making a call to another tool, then it's not so critical, because you know that even if you get a JSON of, I don't know, 5,000 lines, your post query to get something else is probably needing only 5 fields. Then you know what to map. But the agent is writing code, and agents do now. I mean, good agents do now, right? So your tool is also say, hey, write a code to get this from blah. Then you're passing the entire context of the customer into that write a code. And that has access to your entire customer data. That's where responsible AI comes into picture, right? Number 1, you contextualize it. And number 2, understand what's in the context. Number 3, you sort of get only what you want, which means to say that your transaction systems also have to be built better. You need to write layers on top of it. Sorry, I didn't switch off my phone, my bad. Give me a second, all right. Yeah, we are good. So, which means you have to get that. You have to have systems to have only that. For example, your get API could be to say question mark, something is equal to blah. You're able to add a filter on top of it. That's the additional thing that probably you need to do, right? So, I mean, like I said, at the end, if you have time, we'll take questions. I have just 5 minutes. There's a lot of stuff to run through. Yeah. So there's a large diagram here, but I only focus on 2 things, right? One is feedback mechanism, which is very critical. What is feedback mechanism? It refines the LLM prompts, yeah, using prior history. If the system had made an error in the past, you should be able to correct it the next time you do it. If a system went beyond the line the last time it made a call, you should be able to correct it, right? And you should have the ability to read from your previous responses so that you're better. It's like meeting a person, right? The first time you meet a person, you have a conversation. The next time you meet, you have the context. You say, oh, this person is temperamental. I need to be softer. Oh, this person is funny, so I can go beyond the line. This person is very to the point, so I need to do the point. So you have the previous conversation in your mind. Agents are no different, right? So this ensures that if feedback mechanism A is doing good. Number 2, how do you get transparency and accountability, right? See, it's very important that you have an evaluation model that checks for example, certain biases, equities, and representational accuracy. What I mean by this is, I'll sort of give you an example. Let's say the customer is making an auto claim and is conversing with me on something else, right? I need to be able to have that representational accuracy and bias to say the customer is in pain right now. I'm not going to sell the customer. The agent is not going to become salesy, right? Because I understand that my current bias towards the customer is one of empathy and not one of salesness, right? How do you do that? That is where you need to have systems in place. Now, fairness check as a simple box looks nice, but then when you build it, it's fairly complicated. But the point is, we only have half an hour to discuss. Maybe if we have more time, we will go in more detail. I don't know, we can talk about it. But the point here I'm trying to drive is you need to have a box, yeah, where we're all out of time, I guess. I'll put three things. Intent, last outcomes have to be fed into the fairness system to ensure that your next responses are getting better and better and better. That's all, okay? Let's switch to that. I don't know how good it is on the monitor, but then I'll only talk about two layers. I'll not talk about the LLM and RG layer. This is very fairly common. ChatGPT will give you a much better example. Access layers you already know. There are essentially two or three. One is a socket-based chat interface. One is, of course, the batch interface. The other is your API gateways where you are connecting outside. We'll spend a little bit more time on two parts, data pipeline and which is the most critical thing. Number one, ensures that representation across demography. So your data is not really so narrow, that it only knows male 35 years IT. No, right? Or female 20 years, something else, doctor. It doesn't know. It's not narrow, right? That ensures that when your responses are going back, it understands contextually what is happening around, right? And if it is smart enough, for example, when all the blackouts are happening a couple of days ago, it doesn't tell you something very, very stupid or funny because people are under pressure there, right? So you have to understand that. That's what I mean by bias detection. You need to have proactive identification. The word proactive is very important here because it cannot be that the customer telling me, hey, you know what, this is not right. Please correct it, right? And then the most critical piece that we have to understand here is for balanced data splits in training and testing. Irrespective of whether you are only relying on the LLM to do it, when you pre-tokenize it, when you put it to the embedding, I think you should ensure that you are able to sort of get to know what to tokenize, get to know what to embed, and then embed it. Basically, you need another loop in between. That's what it means. I think we have only 3-4 minutes. Maybe I'll take a couple of questions if you guys are okay with it. Then we'll spend a little bit of time on what is this. The most important thing I want to talk about here is you need a decision explainability. You need to be able to store, log what you said so that you can human audit it later. See, once you get this is running on by itself. It's like a loop. But you should have the ability to, for example, log, store everything that has been reasoned. It is like explain that you do, when you use an agent, right? You say explain what you're thinking, how you log that thinking, because then later point in time, if there has been a bias, if there is an error, why it went wrong. Yeah? Because the LLM is not a very deterministic system. The same question you ask it thrice, you will get 3 different answers, right? But at least you'll be able to log and figure out to say what is happening, why did it make this particular bias, is there something wrong in my data, I'm asking it in the wrong format, is the history not getting sent appropriately, etc., right? Of course, then closed loop improvement based on operational insights. This is where operational human beings are getting into the picture. They're trying to correct it. And there's a lot of content for half an hour, but then we'll try to see if we are able to do a good job. I have 1 minute. Yeah, cool. So let me just close with this. Every system determination should be explained and traced, which means you first have to log and audit it, number 1. Number 2, architecture should support emerging governance requirements. Today, the government may say do this. Tomorrow, the regulations may say do something else, right? Your architecture should essentially have the ability to support it. Bias prevention has to be there, and not only at the time of ingestion, not only at the time of calculation or inference, throughout the life cycle is important. So as long as you're able to put it everywhere else, filter checks, for example, this should work. So this multi-tier LLMs that right? I mean, you ask it, then there's another layer that checks, is this answer right to say or not? For example, continuous improvement process, this is okay. Of course, the critical piece, again, if you're building really responsible AI applications, you will have the ability to combine your batch input processing with real time to ensure that you're getting the same kind of an output, right? Yeah, this is what I had. Maybe I have one question. I don't know if you're taking questions later. Okay, so I have 58 seconds. What do we do? Yeah. Anyway, cool. I mean, thanks for having me. I thought we are doing questions right here on the floor, but we'll do it later, it seems. I'm there for a while. I don't know if you want to kind. Yeah, thanks a lot. Thanks a lot. Thanks for being a great audience. And being here at 10:30 is actually a problem, right? You cannot time both Bangalore traffic and stock market. We all know that. Thanks a lot. Yeah. See ya. Bye.
Check. Thank you so much, Harish. I'm so sorry we could not take any questions, but he's just right outside the hall. For anyone who likes to connect with him, please do connect with him. And please do connect with him on LinkedIn for any other questions as well. Okay, we will quickly move on to our next session, which is titled From Warehouse to Lakehouse, the Future of Real-Time Data at Zepto. The session will explore the evolution from traditional data warehouses to modern lakehouse architectures, focusing on how real-time capabilities are reshaping data engineering. This session today will be led by Abhinav Raghuvanshi, Associate Director of Data Engineering at Zepto. An IIT Delhi alumni and seasoned data leader, Abhinav brings rich experience from his time at Uber, UHG, and Pika. At Zepto, he plays a key role in building high-performance data infrastructure to support the demands of India's leading quick commerce platform. Ladies and gentlemen, can we have a huge round of applause for Abhinav, please?
Hello everyone, welcome to the conference today. I'm Abhinav, I lead data engineering at Zepto. I'm not sure how many of you know what Zepto does. But yeah, I'll walk through what we are doing, what we are building in terms of real-time data, batch data, and everything, right? Okay. We are Zepto, right? Zepto is a quick commerce delivery company wherein we deliver quick commerce goods, FMCG goods in 10 minutes kind of thing. And it has been a revolution in terms of everybody moving to a delivery space wherein now everybody wants products to be delivered within 10 minutes, right? And 10 minutes is something that Zepto came in with. Now Blinkit, Instamart, and many other players are doing it. So if you see what is our USP is 10-minute delivery, right? And then we have some multiple products like Super Favors, Zepto Cafe, the latest one, and 1200 data dark stores that we have right now, right? Which is because of which we are able to serve the delivery of users or basically the products within 10 minutes. It's a very complex model wherein what we want to do is basically serve all the data and all the product needs of all the user base so that you don't need to wait for a longer period of time. For example, if I want, let's say, Maggie packet, right? I do not want to wait for a day when the Maggie packet arrives, and I want to serve it as quickly as possible. So behind the scene, a lot of data crunching happens, and that is being powered by the data platform at Zepto. This was the legacy architecture. We started everything, building everything, all the data marts, data reports, analytics, machine learning, everything on top of Redshift. If you see the legacy architecture on the left, we have all the sources. We have event data, which is primarily unstructured data, coming as a JSON and a non-structured format, right? And there are RDBMS, Postgres, which most of the companies have for their transactional processing. We also have files, logs coming from multiple places for basically monitoring how the app is working, how different parts of your systems are working and stuff. We have external data coming in. For example, we have payment gateways integrations. We have multiple other third-party integrations that enabled us to reach the stage that we are, right? And we need all this data to enable analytics, intelligence, to serve our customers much better from day one, right? In the legacy system, we were using Hivo as a primary ETL tool. We were, I think, a couple of engineers in the team. We wanted to have a quick, basically, analytical platform setup. We used Hivo as a tool to just ingest data from all our OLAP systems, OLTP systems, event structured, unstructured APIs, and everything. And then we pushed it to a Redshift cluster. We initially started with a single data warehouse on top of Redshift. With time, I think within a 6-month kind of thing, we realized that this is not going to scale. Then we kind of evolved to a data share kind of architecture where we had a single writer instance and have multiple reader instances, and primarily for operations, growth, business reporting, applications, and other things, right? And those were kind of tied up with reporting tools like Superstat, MicroStrategy, applications, and multiple other internal tools, Excel being, I think, widely being used across all the industry for analytical use cases, right? What we realized was the way we were kind of pushing data into Redshift with the volumes that we are getting, the speed that we wanted to serve, it was becoming impossible to serve data in near real time. We often had to wait for D-1 data and then probably serve data on the next day kind of thing, right? Which obviously led to issues in terms of getting stale data while reporting. For example, I want to run analytics, I'll have to wait the next day and then I will run analytics, but I will never know the state of my operations at the time T, right? If let's say a warehouse or a mother hub or dark store is not performing well at this point of time, obviously we can track it through the application databases, but it's difficult to run analytical queries on top of OLTP systems. But here, because all the reports are being run on top of Redshift, we often led to basically having delays in terms of identifying issues in real time, right? Yeah, so these are the challenges that we had with a legacy architecture. This is what I talked about, basically scalability, cost, no federation, long query wait times, because again, it is a single basically machine. If let's say somebody is running a very bad query on a Redshift cluster, right? It will choke all of the other users on the same cluster, which would ultimately lead to most of the reports getting delayed, or basically people not being able to do the analysis on time and stuff, right? No segregation between storage and compute. We were using RA3 machines wherein we used to have the Redshift storage as a primary storage. Obviously, we can use S3 as external storage and then query through external, basically external tables, but those were kind of very slow for us, for our use cases. So that is where I think we started thinking in terms of what should our future basically architecture for analytics layer be like, right? And we were kind of doing experimentations on top of Woody, on top of Iceberg, and obviously the Delta. But given the state of time we were in and the capabilities that Databricks used to provide, we decided that Delta is the format that we should go ahead with, because it was able to serve all our use cases, right from basically scaling infinitely for the compute resources. For storage, we are using S3, and basically it was working fine for example, partitioning, and multiple other features are there on top of Delta Lake that we can use for enabling our analytics, right? If you see how the basically the architecture looks like now, is we get CDC data from all the databases primarily through Debezium, wherein we get all the vol logs and change streams from Mongo, right, into Kafka in Avro format primarily. Avro because we wanted to compress the data in MSK layer, and we had a schema registry built in so that everybody knows the schema of the data. There were some capabilities in terms of what was being supported at Debezium, I think a couple of years back, 1.5 years back. But we made few changes as per the need of Zepto, and pushed obviously back into the open source Debezium in terms of enabling our needs and pushing our what we are doing into the back to the Debezium system, right? We pushed data into MSK, and then after MSK, there were two approaches that we could have taken. One was directly use Spark and then push data into Delta Lake in the, let's say, upsert or the append format, but we went ahead and went with the S3 sync connectors primarily. For all the analytics use case where the data is not needed real time, basically within a minute, within 2 minutes kind of thing, we went ahead with the S3 sync connector kind of approach that enables us basically two things, right? One, S3 now serves as a storage layer for all the logs we are getting right from the databases, change streams, the event logs, everything. And two, basically you don't need to worry about the cost, obviously, because we are running on Databricks. We do not want to just burn compute just because we want to dump data from point A to point B, which can easily be done by something like Kafka Connect, which is basically Java-based application pushes data from MSK to S3, right? From S3, the entire platform now lies on top of Databricks, right? Right from bronze layer to silver layer to gold layer. What we do as part of our transformations is basically remove the PI columns, clean up all the data basis business requirements, load it into a silver layer. Silver layer is up for consumption by all the analysts, data scientists. If somebody wants a snapshot of data at any point of time, that is the way to go. But bronze layer obviously serves as a time series state of a data. If you want to say what was the state of my, let's say, stores table couple of months back, right? It's easy to go to that log table and then figure out what was my basically various dimensions of the store at that point of time. Databricks obviously have Spark as a native engine in terms of processing. It also comes up with a Photon engine, which serves well for some of the use cases, some does not, obviously. So roughly around 10% of the use cases, you make use of Photon engine for processing faster. On top of the entire Databricks, we have built our own in-house framework because we have roughly around 300, 400 analysts, right from business, product, the operations team, and control tower team or downstream operations business, right? And not everybody is well comfortable in terms of writing codes on top of, let's say, a Spark code or something, right? So we built a framework, in-house framework, which is a simple plug and play kind of thing, kind of no code, low code ETL solution, when people just need to pull in their SQL queries. Most of the analysts are very comfortable in also writing SQL queries. We have put in abstractions in terms of what transformations they want to do and stuff, and ultimately it is scheduled on top of Airflow and obviously on Databricks for running the jobs in the end, right? For, let's say, hour latency, 15-minute, 1 hour kind of thing. Now the major problem comes in that how do you control cost, right? We have built in budget thresholds for each and every business functions. Databricks, we are primarily using Unity Catalog for access management and tags which are present at the jobs for isolating resources and stuff, so that each team has their own budget thresholds being capped at, let's say, X dollars dollars and stuff, right? And again, we have basically alerts set up on top of those thresholds so that people are aware in terms of what data they are consuming, how much compute they are consuming and stuff. What it has enabled us is, instead of worrying about when the data would arrive, it gives more control to the end users in terms of what frequency the data they want to consume, right? Because here the computes are kind of infinitely scalable in a sense, because you can just put in more machines as per your use cases, business justification, and then run your jobs, right? Ultimately, because all the control eventually lies at the hand of the user, they don't need to worry about, okay, we have to rely on data engineering team to run a load, to load tables, figure out when the data would load and stuff, right? The end users can run their own jobs on their own sweet time, schedule their reports at whatever time they want to, and ultimately making their life much easier in the sense that if, let's say, there is a business use case to monitor, send out a report at 11 a.m. morning daily, they can then schedule their reports at 11 a.m. without depending upon other systems, other teams and stuff, right? Because all the data is anyways flowing in real time to S3 data lake and the bronze layer, and everything on top of that is ad hoc kind of system. It has enabled us solving most of the use cases of the analytical layers for ML data science use cases, right? Database provides a very good interface in terms of building jobs and stuff. Prior to that, people were kind of running their own notebooks, figuring out how much compute I need to have and all those things. That kind of gets abstracted from the data science people and stuff. We have our own CI/CD layer built up on top of the entire system, right? Wherein there are some use cases wherein people actually need to push in notebooks to the basically GitHub, and then those GitHub basic notebooks need to be validated and then pushed to the jobs, and so that the notebooks could run on time and stuff, right? Some of the governance that we have put in, apart from just the resources and number of machines that somebody can spin up, is around the runtimes of the report. Until now, there is a specific business use case to churn data beyond a certain period of time. We limit saying, let's say, 1 month of data, 2 months of data, 3 months of data, depending upon the size of data, nature of data, and other things, right? That has enabled us in terms of saving cost and also gaining performance of the jobs as a whole. And this has been working fine for us, I think, last 1.5 years, right? One very good feature that we use basically one good feature that we use for sharing data between third parties and us is delta sharing, wherein you don't need to physically share your data. It is through a delta share mechanism. It is secure and very easy to basically collect the data from third parties as and when you want to, right? You don't need to worry about when the third party has sent the data back to your system, is your system working well or not. If they have a delta sharing mechanism, it becomes easy. Whenever the data is pushed to their system, we can just query those tables and basically consume as per our use cases, right? And ultimately here also, if you see, we have Looker, Superset, and some Databricks dashboard built on top of that. There are some applications also which consume this data on a daily basis, on a hourly basis kind of thing. The only challenge that we have, at least from the lakehouse point of view, is the applications cannot have a sub-second response on top of a lakehouse, because primarily S3 is your storage, and then if your QPS is higher and you want real-time data to be served in basically in milliseconds, it is generally not generally not feasible because it is some seconds to 10 seconds kind of latency. And that is where I think we built a parallel system for real-time architecture. Yeah. So in real-time system, right, what we wanted was we wanted all the metrics that are P0 metrics for the business to be served real time. Basically, here we means whatever data comes at 12 p.m., it should be available by 12:01 at max. No more latencies, no more delays from that, right? That is where a system like ClickHouse comes in. It is a OLAP engine. Most of the people might already be aware of, but it helps us in basically running queries on a millisecond latencies. Basically, query times are much lower than a traditional lakehouse. Lakehouse works well when you want to scale data, people want to do analytics and stuff, but ultimately in production, you would not want your application to just show metrics after 10 seconds, 5 seconds and stuff, right? That is where a system like ClickHouse comes in, right? ClickHouse primarily a OLAP system. What we do is, because it does not support joins very well, at least as of now, though it supports some of the simple joins wherein you have a dimension table and stuff, we use Flink as a processing layer in middle. Flink primarily because we want to manage streams and do some enrichment on top of data and ultimately push data into a ClickHouse system in a denormalized form. If you see there is a RDS system in the middle, it is a primarily Postgres. Earlier, before moving to ClickHouse, we used to serve our real-time reports using basically Postgres. It worked well for some time because the data volume were lower, but with time, the more complexer queries we want to serve, it became impossible to serve using RDS, right? And that is where I think ClickHouse came into the picture. In Flink, again, because here also we don't want people to worry about writing Flink codes in general. Here we have built an in-house wrapper on top of the existing Flink as a framework, wherein people just need to again plug in their SQL queries through a Kafka table engine and other things, and then process, enrich, view in real time how their data is looking into, and then we push that data into ClickHouse for applications to consume. This data is primarily consumed by applications and not by analysts in general, because if I'm an analyst working on a query, a couple of seconds does not matter to me, but if it is an application, it becomes critical that the data is loaded in milliseconds kind of time, right? So if you see the use cases that we are serving are for the control tower analytics, monitoring of P0 metrics like traffic surge, drop, order loss, etc. Streaming IoT data, because if you see from the business model point of view, we have dark stores and basically mother stores, wherein we store items like ice cream and other things, wherein we want to manage temperatures and various other metrics in terms of whether the products that are being kept at the warehouses are safe to consume and all those things. Apart from that, we have to track our trucks and all those things. For that also, we need to have IoT data to be sent into our systems, and reporting needs to happen on real time, right? Because it cannot be that we just shipped our truck and we are not able to track when the basically truck would arrive at our store, right? So all those metrics are captured by the IoT system, pushed into ClickHouse for real-time analysis, reporting, monitoring, and other stuff. So what features did ClickHouse provide? Why we moved to ClickHouse for real-time kind of thing, right? Because obviously it provides a low latency data ingestion. ClickHouse has multiple types of ingestion engine, right from Kafka engine to Delta engine to S3 table engine. We use them for ingesting data into ClickHouse. We have table engines wherein you want to process the data, for example, merge tree, right? There are multiple kind of merge tree engines available, a basic merge tree, replicated merge tree, replacing merge tree, summing merge tree, collapsing merge tree, and all those things, right? Merge tree works very, very well for data like event data. If your data is immutable, feel free to just dump into ClickHouse in the form of merge tree table. Basically, it is kind of log table wherein you can write a single table OLAP queries to get the metrics out of the system very quickly in milliseconds time. Basically such kind of, the merge tree helps us, at least us, in terms of monitoring, for example, how the order purchase is going, how the payments are going, how is the traffic on our home screen and all those things, right? If there's something blunder has happened. In Zepto, we run a lot of experiments time to time in terms so that we can basically help basically improve the experience of the users, and that is where monitoring systems in real time is very, very important. We use Mixpanel heavily, but with the scale that we are growing, it becomes very important for us to monitor, have these systems monitoring in place internally, and that is why we're using ClickHouse for merge tree kind of use case, right? We have replicated merge tree wherein basically from the ClickHouse architecture, if you have multiple nodes, you want to replicate data around nodes, have a highly resilient systems in terms of data availability across the node. That is where we use replicated merge tree. We have replacing merge tree for use cases like where you want to do upserts, right? Any OLAP database is not built for upsert. It is kind of replaced for non-mutating data, but replacing merge tree provides that capability through internal mechanism where it first upserts and then deletes and updates behind the scenes, so that end user does not need to worry about managing the complex ETLs, right? That is where replacing merge tree comes up. Summing merge tree is kind of aggregations, on the fly aggregation. Somebody want to know, it will, if you do the order by of data on some, let's say, dimensions, it will be automatically doing aggregations behind the scene. That is where the summing merge tree come in, right? And so yeah, I think from the consumption standpoint, it has enabled basically columnar storage is there. Hence, the footprint of the data in ClickHouse is much lower. We have seen cases wherein the size of the data has gone by level of 10x, wherein let's say 400 GB of data became 40 GB of data in ClickHouse, primarily because the compression is heavily enabled on that, right? Auto rolling is there. We have TTL enabled on most of our data sets in ClickHouse. From the GitOps point of view, at Zepto at least, we make sure that all the Git best practices are in place, right? From basically creating tables to rollback to alerting and stuff are basically enabled from day one, and that has enabled us in terms of onboarding newer use cases much faster and stuff. So yeah, the bottom snapshots are not from the live, the actual application, because our supply chain basically tooling is a proprietary tool. But the metrics are kind of what we actually monitor in real time, right? For example, inventory availability. We want to monitor how much inventory of let's say, for example, milk is available at 8 a.m. across stores, right? And this system has enabled us in terms of monitoring real-time inventories, so that let's say if your milk in a store at 10 a.m. is getting exhausted, you want that milk to be refilled in a store by 2 p.m., you should have that data available at 12 a.m. basically, right? That is where it has enabled us in terms of monitoring the availability in real time. We have live inventory snapshots running. We have store metrics, how the stores is performing, right from packers to riders, to different matrices in the stores, how the bin capability is allocated and stuff. Ads metrics are something that we monitor in real time. I'm not sure that if you are aware that we have an ads platform which is built primarily for brands, and brands want real-time metrics to be available, right from click-through rate, conversion rate, and all those things. We power those from primarily from ClickHouse-based system, right? So yeah, so values unlocked by moving from traditional system to Lakehouse and ClickHouse kind of system, right? It's low latency data-driven decisions. We are able to monitor metrics in near real time. The availability of data is forever, and you can make decisions in real time, right? Improved analytical reporting. As I mentioned, that you have very less delays. You identify issues much faster. Fixing becomes easier. So let's say, for example, if you have an issue in your base data, and you identify 3 days later, that means your lot of reporting must have gotten impacted, and you realize at a much later point of time, rather than just identifying right there, right then, right? Improve time to detect. All the business metrics, because we are tracking in real time, near real time, it's very easier to track in real time, because we understand our business, and we know what metrics, how should those metrics behave. If there is any significant change in terms of the SLAs, the ETAs, and all those things, we kind of track in real time. Any bottlenecks in terms of, let's say, somebody launched a coupon into a platform, right? We will obviously see a difference in terms of how our home screen imprint is, let's say, or is there some experiment running? How is the impact of that experiment in real time? At Zepto, we want to track experiments in very, very real time. For example, if we have launched an experiment, we generally track within 2 hours whether that experiment is behaving well or not, because given the way that we function, we cannot wait for 2 days, 3 days to just figure out, get the metrics in place and see how experiment is behaving. We tweak experiments, we monitor experiments in real time. And obviously it has improved the team productivity a lot, wherein we had to basically struggle in terms of ingesting the data, working with different folks in terms of why you are running query on cluster on a single Redshift cluster, choking all other business users. It has significantly improved the productivity of data team, because now people can focus on building more data products out to the ecosystem of the basically Zepto users. The failure management, RCS have become much easier. I think most important thing is the faster reporting and the platform improvement that have come in because of this. So future roadmap, if you see what we are looking for is, right now we kind of use ClickHouse, but as I mentioned that we'll have to put data into a denormalized form. Obviously it requires some kind of expertise in terms of knowing how the data should look like. For example, if you want to just backfill one of the dimensions or metrics, you'll have to then reprocess the entire data and then push into ClickHouse, which is a tedious task for data engineers, for anybody, right? That is where I think the new systems like StarRocks and other OLAP systems that are coming in the market, right? We are exploring those systems, seeing how we can make those joins in real time much faster. And we are experimenting with StarRocks majorly for such use cases, and obviously building some of the capabilities on top of ClickHouse so that the joins are supported again across 2 big tables and stuff. So yeah, I think that's pretty much from my end. If you have any questions, I think I'll be good to take that.
Hi, thanks for the presentation. So I had a question around upserts actually. So you said you are using ClickHouse for upserts, right? Are you using upserts for Databricks as well? Probably using CDF, or in some way you're trying to upsert and only find the data, like restrict the data to a certain, only the upserts when you take a source?
Yeah. So in ClickHouse, yes, we are doing, and that is where the replacing merge tree we are using, right? There you define by the primary key, which is defined by the order by syntax, right? For Databricks, it is very important for us to maintain upsert, because if you see, we are getting all the change data from the RDBMS, right? The RDBMS change logs will always have a insert, upsert, delete, and all those operations coming. Delete obviously not for most of the system, but in cases of purges and TTL and all those things, you'll get deletes, right? In the silver layer, if you see, right, that is where we are processing this inserts, update, deletes in the order that they arrive in, and we regenerate the records in the correct order. So upsert works on delta table. Delta, again, because it provides asset properties, we are upserting data on top of that.
Okay, so one follow-up question. So basically you're orchestrating everything through Airflow, right?
Yep.
So the moment you run your Airflow task, the data would get full refresh, like create or replace table would happen.
The entire table will never be refreshed, because if you see, we are capturing CDC, right? So you only capture the incremental data, dedupe that data on the fly, and then merge it back to the main table.
Got it.
So that you don't have to touch the entire table again and again, right? Because that is not feasible. Obviously, it works if you provide more resources, but that is not scalable in the sense, let's say, one of the inventories example was, let's say, 2 years back, and today it got updated. Today, if you want to update the entire inventory again, that is a pain. But you would ideally want that specific inventory to be inventory or time period of that inventory.
Maybe we can have one last question as we are a little short on time. And please refrain from asking any follow-up questions, because we're running out of time.
Only one question I had was, so whatever we have in the lakehouse and the data that we have for real-time analytics, right? It seems to be 2 separate paths. Don't you think that it is siloed?
No. So it is not, because if you see what we are trying to serve through ClickHouse are the proper business metrics from the application point of view, right? All the analytics data, that is primarily on the lakehouse only. Any transform data where we denormalize the table, that is what we are putting into ClickHouse, not the raw data as it is. So as a result of which, we are not duplicating data, we are enriching the data and pushing. For offline analytics, we push that data back to Lakehouse again, so that data is available forever.
Okay, okay. That's where I wanted to understand.
Thank you so much, Abhinav. We're so sorry. We know you have some time, but please do connect with him outside. For any more questions, he's available outside, so he can give you some more insights. Cool. Can we have a huge round of applause for Abhinav? We had a house full for your session, Abhinav. Thank you so much for that amazing session. Before we go to the next session, just a quick announcement. AIM Leaders Council mentorship program is happening right opposite the registration desk at the entrance. It's a perfect opportunity for all you young analytics and data science professionals or students to interact with successful professionals in the field. So please do register with Purvi. She's taking care of it just right outside the entrance, and fill in your slots next. For the next session, we have Unlocking the Power of Your Raw Data. This session will explore how Redbus built a smart data platform component that converts raw user interactions into queryable Parquet files on S3. Attendees will learn how features like auto schema detection and schema evolution enable efficient debugging, analytics, and model training at scale. This session will be led by Ravi Kumar Kumaraswamy, Vice President of Engineering at Redbus. With over 27 years of global experience across industries like banking, capital markets, and transportation, Ravi Kumar has spearheaded numerous large-scale digital transformation and data platform initiatives. Ladies and gentlemen, can we have a huge round of applause for Ravi as he comes on stage?
Good morning. No energy. Good morning. Thank you. Thank you. I want to make it a little more interactive. Let me start with a question. How many of us are here are transforming streamed data into lakehouses and data warehouses at 1 million events per day scale? Anyone here? Cool. One. Anybody else? Okay. Cool. So, sir, I will have a follow-up question for you. Do you persist the raw data? The raw data after, what would be the duration for the raw data? 1 month. Why?
That's coming in.
Yeah.
So it doesn't make sense for me to have a very longer retention for that.
Absolutely. Thank you.
Yeah.
Thank you for that. Well, so today I think we are going to talk about how we innovated in terms of persisting the raw data and use it forever. We don't lose a single event that is streamed into our platform, data platform. That is what we are going to see, what kind of innovation we have done. So let me start with a quick round of introduction. So Redbus, as you all know, it's a ticketing platform. You all know that. Do you know MakeMyTrip, Goibibo, Redbus, all are the same company? Okay. So all three brands essentially are the same company. Okay, and I'm specifically from Redbus, where we have done this innovation, and we are going to talk about this. So there you go. Our unified data platform, as I was indicating, so it is actually processing about 1.75 billion events every day, and it processes about 150 billion data points every single day. To give you just the scale, and we don't lose either of them, I mean, not a single of them, right? And this data into the data platform, what we do is, we have powerful ways of, powerful avenues for our stakeholders across product, tech, marketing, business, CRM, to derive analytics and use it for real-time decision making. So that is what our data platform is used for. And I think the few of the presentations before, pretty much it's the same, but I would still would like to quickly walk through this particular slide. So, okay, it works. So if you see the source, right, the source from all our channels like your web browsers, applications, backend servers that stream the data continuously into our platform. And we ingest this through Kafka, we ingest through RabbitMQ, and no HTTPS and no files as well. So based on the nature of the data, we have different processing. For example, the streaming application, the streaming applications data, it is getting processed through NiFi and Flink, whereas the batch data, we process through Fargate, Lambda, through GlueJobs. And storage, again, it depends on the nature of the data. For example, Imply, which is nothing but your Druid, Apache Druid, it's a product they've created on top of Apache Druid. We save all our real-time user behavior data into that. And this is enormous in number, and the data, Redshift stores the data marts and warehouse, etc. The consumption layer, as commonly, superset seems to be the industry standard. I've seen in the previous two presentations as well. We also use superset, and also we have got something, a proprietary lenses, which I will talk about, in the later slides to come. We have alerts passing through emails, webhooks, and we have monitoring, Grafana, Prometheus, and orchestration. The infra orchestration, we have Kubernetes, and the task orchestration, we have Step and Airflow. We have also created documentation, a dynamic documentation platform. It's called using Docusaurus, where our data platform can be democratized. We have democratized our data platform using this documentation platform, which we call data catalog. So it is a very unique proposition. I will give you a glimpse of that as well as we move forward. So going to the next slide. Okay, this is the data catalog that we have created. If you see, there are multiple business, the nature of the data here on the left side. I can click on that and find out all the tables under that, the warehouse tables. It also gives you how many rows are there, what is the size, who is the owner. If you want to talk to them, or if you want to visualize, you can directly click on this, visualize, and go from here. So it's a very innovative innovation that we have done, but we are not going to talk about that. We are going to focus on the real time. How are we going to persist the raw data and build power to leverage that? Okay, why raw data? As he said, why do you want to persist for a month, sir? So.
So data is changing quite frequently. So we had a transactional system which were like getting the data as a batch, and real time is something for operational purposes. Right. So don't keep it more than a month.
Yeah. So what kind of use cases you have built on real time?
So I come from a food delivery domain, right? So we had that. We have to do the operational monitoring, see how the riders are delivering at the right time or not. So, and for the machine learning algorithms. So
excellent, yes. Excellent. Thank you for that. So exactly, we also figured out the raw data is of enormous use, in terms of troubleshooting. Because when, for example, a booking failure happens in Redbus, to figure out just the information what we persisted is not enough. And what we need is the real raw data that was sent by the API. So for that, that is very important. Second, the data science, many times they come back and say, hey, you know what? I want to build this a use case in the model. I want the data, and I want to capture this. It can be only, it cannot be retrospective, right? It can be only prospective. So how do we build retrospective at scale? So that is why we need the raw data to be available for us to process. So these are the cases why we thought we should start looking at the raw data to be persisted. To give you the scale, in our apps, it generates about 57 million events every day. I'm talking about only the 3 critical applications, the APIs. These 3 APIs, 3 sources, it generates 57 million events every day, which is like, huge, right? So if I have to save assets, it is going to create a data swamp. I cannot save assets. I have to find out an innovative way of how I save it more optimized manner. That is what is the problem that we had in hand. And also it should support how we can scale it, right? And also how we can leverage by using the potential, right? So these are the challenges that we had. Now, if I look at that, how we have the steps that we have taken to actually solve this problem is, first, we understood that data which is coming in is through APIs, which is pretty much a contract exists. So it is between the systems. So if there is a contract, I already have the schema. But the challenge is the schema is ever evolving. Every day it evolves, right? As we grow, we introduce new fields and information into the schema. So it evolves. So we thought instead of tracking the schema, we thought why don't we infer the schema from the raw data? The moment the raw data hits us, we will go and find out what is the schema. Then what we do is once we get the schema, we will go and compare if the schema already exists with us. Already we already versioned it and it exists. If it exists, we will add to it with a new timestamp as the ID, or we will actually create a new schema itself. If assume it's a new event that is coming in for the first time, then it creates a new new bucket. So these buckets are created, timestamp and version. Now the bucket is there. The schema has been inferred. What we do next, we take the raw event, we actually do a upcast, the casting. We have some casting rules which we'll talk about in the coming slides. We do the casting and we actually transform this event into the generic schema that we have inferred. The generic schema, what we have inferred, we transform this event into that. Then that data is getting compressed at the next level of optimization. We put this into a Parquet. Of course, Parquet is the data lake, new norm. Because of this efficient columnar structure, how it's store the JSON data. So we use Parquet, but again after we transform into a Parquet, we actually merge this Parquet and put it in S3, and that is how we actually these are the steps that we use to process this. Yeah, so this is the schematic, the schematic diagram that represents how we actually inference. What pretty much I explained you. So first, when the API services push the JSON, we through Kafka, we take it, we extract the metadata. The metadata, what we extract is, because of luckily and fortunately, we have headers uniform across our API services. So like your country, your event source, etc. So we extract this. We include these elements into that event data itself. We include this metadata into that so that it can be queried, etc. And then we infer the schema. As I said, after inferring schema, we just go and do the schema bucketing. Once we bucket it, we transform, then publish to S3. So also what happens is because of the very nature of our business, we end up generating small files, a lot of small files, which is a problem. So now I have to do a compaction. So the small files get compacted using this flow that we have indicated here. The small files are now identified, merged into Parquet files, and we publish it. So we have optimized that as well. So this is what I was referring to, how we actually do the casting, right? The raw data, if you see, these are the elements: time, source, country, then ID description, ID amount, success total, etc. So now we actually derive a generic schema out of that, which is like, which is in the middle, right? So this is the generic schema we derive from the raw data. Then we convert this into a Parquet schema. So once we do this, and also we have just captured, just in case if you are interested, if we have time, yeah, we have time, I'll go through this. So how we actually defined, because we have controlled how this upcasting will happen. For example, integer long, it is resolvable to long. Float double, resolvable to double. Boolean long, it cannot be resolved, right? So it cannot be resolved. Null any resolvable, we can put any. String and any primitive, we put string. So these are, this is just an indication, but there are multiple other rules that we use to actually upcast the actual event data into a generic schema and then to Parquet. So this also explains a bit, no more, just in case if you are too interested. So the two strings, how it is getting converted from the raw data to a schema, and that is a disjoint merge. Then we have mismatch where there is no merge, how we handle, an array merge and a schema mismatch, just to indicate how we actually convert or transform the raw data into the generic schema. And once we generate this bucket, then we have to create a Parquet as well. The Parquet generation also follows a similar approach. Now, as I said, the metadata is our source, country, and event type. That is how it is structured, and then followed by the event time and the bucket ID, and we add the version time dot Parquet, right? Because Parquet file will have the version as the file name. That is how we have structured. And once we have saved into S3, now the next step is how do we actually leverage, right? How do we extract this data? How do we extract and leverage? What we have done is we have created a serverless extraction mechanism where the data gets extracted using application called Lenses. As I said, Lenses is a very important application that we have built. It's a powerful explorer what we have got. When a user inputs, for example, Singapore, I want the booking data from IST 11 a.m. The moment he puts that, this application, it calls this backend service, which creates a Fargate job. This Fargate job actually goes, take this filters version, find out the version, filter the groups, extract the data, and creates a SQLite file. And this SQLite file, it publishes into a S3 path and gives the return the path to the user. So whenever the user wants to visualize this downloaded raw data, he can actually click on this link and view it in the browser. I'll show you how that also looks like. So if you see, this is how. So you key in your event source. For example, Omega is our inventory system. Then we actually put the geo as India. Then event type as tentative booking. Then this is the time, UTC in UTC. Then this is the MRI client ID or session ID, which is very unique, what we have built, like your GA client ID session ID. We have built for our own selves. So once you put key in this, it is going to generate this file here. And when you click on this file, it is going to give you the raw data here for you to check. Here clearly you see there is a fair mismatch error. So this you would not be able to see unless you have the access to the raw data. That is the powerful feature that we have built. Now how people can use the raw data to debug, the troubleshoot the production issues. And just some quick numbers. As I said, 3 backend services is what we have done this. About 2 quarters ago, we have about 45 APIs in all the 3 services. We serve 9 countries. And we have 5 instances, EC2 instances. The total data what we have is 31 terabyte. In the last 2 quarters, what we have accumulated. And roughly it cost us only $500 a month. Only $500 a month. And more than 6 months, we moved to Asia, Glacier. And the AWS, we are basically AWS shop. We have all our infrastructure in AWS. So we have Mumbai, Singapore, and North Virginia for our Latin markets, Latin American markets. Our daily average, as I said, 5.7 crores, 57 million raw records we process. The raw size will be 2.1 terabyte, which means you roughly get 90 GB per hour. And the record size can vary from 1 KB to 12 MB also, because if you search for red bus, it might return all the matching buses with all this information that can go up to 12 MB also. So it's a huge size event that we get. What we have stored is, after extraction is 148 GB of data, and roughly there are about 24,000 objects, S3 objects. The compression ratio, what we were able to accomplish using our innovative IP that we have created for the raw data is 93%, which is 14.5 times. 93% compression. That's how we optimized how we can save this raw data forever, right? And filtering time, for example, for a 2-hour window, I extract this information. It happens in 5 seconds. Maximum, it can be a minute, based on the size of those events. As I said, some of the search events may be huge. That might take a minute maximum. If it is not so complicated, event, it will return in 5 seconds. That is the retrieval, the numbers that we have accomplished. Oops. Yeah, some of the challenges, what we have faced in the solution that we have put together. One is one might think that you lose the fidelity, right? Because you guys are transforming to a generic structure. It is not the raw event itself. You put it in a So here, what we have to notice, we only lose the structure, which can be reconstructed if required, but the information is never lost. The raw data information is never lost, right? That is the most important thing. And matching overhead, and there could be multiple versions of buckets. So will it be a challenge to do multiple, across so many number of buckets? That could be one way of looking, but of course we are doing compaction, but still, this is the question. Right now, we have not faced it. And the structural dependency, I think we touched upon it already. Some of the benefits, as I said, the cost and performance, the key one, we were able to save this raw data, every piece of raw data that we get it into our pipeline for $500 till now. And with a compression of 13x. The data extraction, now how we are now extracting the data is like even pointed, as well as it can be batch processed as well. Batch processed we have still not done, but work is happening. And it has enabled analytics across the board, right from our CRM team to marketing team to our product managers to engineering managers to monitor the new feature launch, etc. It has become the way in Redbus. Everybody uses lenses to solve their problems. Solution highlights elegant schema management, as you would have seen, how we actually elegantly manage the schema. Cost effectiveness, of course, and we can backfill. Any time you can go back in time, and if you want, for example, January 15th, 11 o'clock record, 11 to 12 a.m. Indian time, I want all the record to be reprocessed, we can do. So these are the solution highlights. With that, I want to ask all of you to ask questions, and I'll be very, very happy. And before that, the team which has given shape to this idea is here. Girish and Nitish, if you want to raise, say hi. They are the one who built it. Yeah. So we'll be happy to take questions, and you can also join me. Can we have the mic first? Yeah, mics. Question.
Okay, thank you, sir. Very informative session. So quick question here. So I mean, as you mentioned, we're using Parquet file format, right? And schema evolution is a challenge with Parquet. It's a very fixed structure, right? And then on Parquet, when you do a schema evolution, you have to do an MSK repair. So just thinking, like, are you like considering any open table format on top of Parquet, or it's a plain Parquet, like Iceberg, Hoodie, or Delta?
Link Parquet. You want to take? You can say.
So Iceberg is one thing, because if you technically see, the bucket itself can be represented like a liquid. Right. However, we are working with them. We are working because when we discussed with the Iceberg. So when we discussed with the Iceberg team, so there were some challenges, especially with respect to the evolution of the schema. But our intent now is to see if we can integrate into Iceberg, like as I said, the buckets, right? So that is something that's still
some corruption can also occur, right, when you do the schema evolution?
No, what we do is every time the schema evolves, right, a new version of the thing is created. So the older version still exists, and you can always, when you compact, you can compact to the latest version of the Parquet file as well.
One more thing to add, right? See, Iceberg is it's like a de facto open table format. And Iceberg is very good for change data capture. But as Ravi told, these API events, there's no change data there, right? It is data as it is. There's no upsert. It's just, it's just insert.
Yes.
But yeah, it can be done, but we will be looking into it. But as of now, we don't find a need, but we can easily switch back.
Right, because I think it has read-write modes for streaming options, especially like merge on read.
But here, if you think about it, right, Niti, the whole system, right, we already have the metadata stored. So you can plug in Spark and Flink there. So it is kind of almost de facto Iceberg, but we thought since we already developed this, we didn't want to plug in Iceberg. It can be plugged in anytime. The CDC use case is not there, so we didn't use that.
Sure.
Yeah.
Thanks.
Can we have some more questions? Also, just a request if we can have less follow-up questions so that more people can ask. Yeah, you can.
Hey,
please.
hi.
Yeah,
hi.
Hi, my name is Anubhav. And I wanted to ask you the question around the product that you created yourself called Lenses.
Yep.
What was the exact point and what was the push for it, and why can't anything else in the market do it?
To give a powerful way to query the raw data, because raw data we persist, and we want people to leverage the raw data without much of complexity. So we wanted to make it's like intuitive UI, where they can actually go and look up any pointed lookup in the past, and this can as I said, the forget job gets fired and pulls it and makes it available in the browser for a certain period of time. The user can go and visualize. You want to add?
So just to add to what Ravi is telling, right? So if you see our whole data platform architecture, we have the raw data system, we have the real-time real-time data which is plumbed into Apache Druid, and we also have something called, I think, we also have something called Redbus identity mapping. We call it as rum. Don't assume we are all alcoholics. But I don't know, just wanted to add one more thing. We have another system called tequila. So we always try to name everything based upon alcohol.
By the way, tequila is no text to query, intelligent language. And it is working brilliantly. We have our own tequila.
That's why it's working.
We give a high to our users.
So if you quickly check this, right? So we have a Redbus identity mapping system. We also have Redshift. We also have real-time user behavior system
this one.
getting plumbed into Imply, that is Apache Druid. And also we have raw data systems. So we need a centralized system for people to discover data. So what we will do is, and most of it is for debugging. So if you give a phone number, an email, you give a client ID or a session ID, MRI client ID that Ravi has talked about and all, what will happen is it will give you the real-time logs from a denormalized OLAP database like Imply. But it will also give you the relationships. You give me your phone number, right? In real time, I can also tell you, like, if you're booked, if you booked a ticket for, let's say, a friend of yours, right? So we can give you the whole web of the use cases. Then, based upon your logs, if there is some 4xx in some API events, what happens is they will check where the problem is. We'll go to this raw data database, raw data UI, and okay, the problem is in this particular event. What Ravi was talking about, that omega tentative, whatever the tentative order event is there, right? So I will pick, okay, you know what, from the visibility perspective, there was a problem. I'll come to know what the problem is. Now, I will understand what the problem is, and if I want to find the RCF of the problem, in the same MRI lenses application, I go and check the raw data, and I'll actually get to know what the problem is to its bare bones. So that's what, we have a centralized layer for people to discover data. That's what we do.
A distributed user tree.
A distributed user tree.
Thank you. May I know when this transformation of, coming to the new thing happened, which last quarter, 2 years, 1 year?
Two quarters.
2 quarters.
We have data for 7-8 months, roughly.
So 8-month data, that data, 31 terabyte is actually compressed data. If you can multiply it by 14.5x, that would be the actual size of the raw data.
Right.
And we're only tracking just 3 sources today.
3 sources, just 3.
Just 3.
Okay. So that's why if you see, right, we just told 57 million, but we are plumbing in 1.75 billion. So there's just a very small subset. So we are planning to expand that 57 million to almost 500 million, because we are storing in almost 500 million user behavior insights. It will expand to 500 million.
And the
so right now it's 57.
data points that we showed is actually just the processed ones. So the data points will even explode if you use the raw data, because there you can multiply it by 10 at least.
It will go into trillions.
Yeah.
We can take one last question.
Yeah, please go ahead. Yeah, you take.
So you're talking about the raw data, right?
Yeah.
So
lenses.
Yeah. So this one. So there are a few things. One, you need to. It applies. You can technically apply it to any API data, but one of the biggest advantages one of the things that you need to also take care of is that because you are inferring the schema, the original data contract, right? You have to group them based on, let's say, similar data. Like you can't group search and tentative together. It doesn't make sense, right? So that you need to do. And we as data platform, we've enforced some sort of like mandatory contract, you can say, across all of our event producers. So they put some essential information. So that information is also used as part of the grouping. But you can actually do that, because as long as you have, I mean, you can't do it on images or anything like that, but you can definitely use API data, because technically API data is created by people to talk to, for machines to talk to each other, right?
So just, can I go for?
Yeah, please go. Additional.
So yeah,
we have 3 minutes.
Thing, I want to know that if you can make this intuitive more of like push through our own side, like something, this preemption which we are putting, we can make it more generic. Example, let's say a food delivery system want to use something like this, then something they have to change in your initial grouping of that data, right? So that can be more generic of like a template which we push. So
actually,
that can package this thing as a generic.
So it's a simple library, and what we have is just a pipeline today.
See, you can, of course, it can be generic, right? So, for example, if you're in a food delivery platform, or let's say, let's compare it very quickly, analogous to Redbus platform, right? We have a discoverability page, which is search page. That's what we call. So, at your end also, you have a search page, right? So, the search page, the APIs that will be there in the headers, you will have static parameters like, you know what, the API name is search.
City or country.
Then the country, if you are across countries, it will be like India, whatever, Sri Lanka, and then you will have other parameters also, like what is the what is the channel, Android, iOS, blah, all that, right?
Yes.
So we use that parameters to create partitions in S3.
Okay.
So that is mandatory at any cost in any organization.
And what we built is a very simple extraction lookup, right? It's not even, we are not even gone beyond, let's say, large scale backfilling of the data. That is next thing that we are working on.
I think, yeah, this has lots of potential, and kudos to you guys for bringing it up.
Thank you.
Thank you so much. We have 1 minute. Any final questions, or we can conclude? Yeah, please go ahead.
I think the quick question here would be like, how would you query the version data in, like, if there are 3 versions in a day? How would you query that?
So, as you query, like, because you'll have to understand, one of the problems we had is we don't know if you store, if you actually query the original JSON, first thing is text, you have to translate it to tree, and then you have to walk the tree and extract it. Underlying, it's always the same. So we have it in columnar, so that gives us one advantage. Then you are going, now you talk about different versions, right? You can parallelly extract them, because you can handle each version in its own thread. And let's say if you are looking for an attribute that doesn't exist in the next version because someone added newly, you can skip the whole version. So that kind of, the schema itself becomes a partition for, let's say, newer data. So that is also there. And when you merge it back, so there are some challenges there as well. But when people look for, they actually look for certain part of it. They don't want everything. This is just one debugging use case that we built. But usually if you are only interested in certain set of data, that, as I said, in some schema it may be there, some schema it may not be there. So we can always pick and choose that. And yeah, I hope that is.
Thank you. 20 seconds to go. Cool. Thank you all for coming and giving us opportunity. Really appreciate it. I'll take my phone.
Yeah.
Mike, we can get.
Okay. Thank you, everyone. So, hi, I'll be taking over from now for a few sessions. I'm Sanjana. I'm an associate tech journalist at AIM. Next, we have a session that dives right into the heart of modern finance. It's architecting scalable data pipelines for financial insights. This session explores the principles and real-world practices behind building scalable data pipelines that power meaningful financial insights. We'll dive into architectural patterns, technology choices, and performance considerations that enable organizations to unlock value from their data. Taking us through this session is Mr. Jagrup Singh, Head of Data Engineering at Pyramid Capital and Housing Finance. Jagrup is a seasoned data professional with deep expertise in building and managing both traditional and big data solutions. He specializes in designing scalable data pipelines using technologies like AWS, HDFC, Kafka, Spark Streaming, and Informatica. Thank you, and please join me in giving him a huge round of applause.
First of all, thank you so much, Smitesh, for all the help, and thanks for the introduction. Hi, everyone. Good afternoon. I'm going to walk you guys through how, in the finance industry, you guys can do the data engineering, basically, right? How to do it, how you can build a scalable pipelines, how you can make sure all the requirements that different verticals will have, you can meet that, right? I'm going to talk very less about tech and tech stuff, right? I'm going to more talk about how you guys can put effort, more effort towards, how to understand the domain, and when you have a very good understanding of the domain, how you can convert that understanding to the tech later, right? If you start thinking about the tech at first place, you might build with a lot of cool tech stuff, you can build a lot of stuff, but then later on, if the use case is not getting served, or every now and then some issues are coming up, So that kind of thing happens. So my focus would be to walk you guys through, first of all, through the domain, that how you guys can understand your organization, how you guys can understand your domain. Because data engineering, mostly, if you will see in all the organization, is like a horizontal, right? It's not a vertical. And being a horizontal team, you have to support all the different verticals, right? And if you don't understand the journey of your organization's data, you will not be able to build it definitely. You will be able to not do the justice to the scalable engineering pipeline, right? So the first thing is talking about when it is talked about data engineering. So what are the problem statements in the data engineering, right? I'm in finance, right? So in finance, we have like a lot of multiple why do data engineering even exist, right? In all the organization, there will be like multiple application systems. The data is coming in here and there from a lot of application systems. Some system is throwing data in the database. Some system is exposing APIs to you. Some systems are giving you Kafka events. Some system is giving you data on some storage, some file system, right? So as lot of every organization will have a lot of different application systems that is where you need a good data engineering solution, so that you are able to put all the systems data together and you create a org level view and a single views, right? The second thing, why do data engineering why do data engineering exist is, right? There are like lot of teams eventually you will have around you guys, right? Everybody is doing some analysis. They all got the job to do. They all have come to office to do some work, right? So the way the things happen, everybody is like hitting the databases, pulling some data here and there. They all are creating their own source of truths, right? And at the end of the day, when you see like, for one KPI, there are like multiple numbers, right? So that is again a problem statement that data engineering team as a horizontal should be solving, right? The another thing is data discoverability. It's like follows up the earlier one, right? Now, let's say if data engineering team is able to create the data, able to create an enterprise level data, then how can everybody in the organization can discover it, right? That's kind of another problem statement which most of the organizations are having. Last thing is like my favorite topic, data governance, because what I see a lot of organizations do, like they put a lot of effort onto the development, right? And very less effort onto thinking about how we're gonna maintain, manage it later on, right? But I feel like you do the development once, right? It's not like that you're building every pipeline every other day, right? You build the pipeline, you live with it for some time, right? That living with it is like how you build your governance, right? So that you can live with it well, right? So we in our organization put a lot of effort onto governance. How do we, what are the best practices that we can set up for the governance, so that you are able to maintain, manage very nicely what you have built in your field, right? Okay, so this is again talking about kind of problem statements that you will have in each of the organization, right? Everybody is doing some analysis. Somebody wants to do some analysis in its respective domain, maybe risk collection, FCU, or whatever, right? Somebody would have like a lot of questions, right? Where can I find the data? What is the source of truth of the data? Who has created this data, right? How can I trust the data, right? All of those questions would be there, right? So this is again a problem statement that the organizations will have, and that's why the data engineering team have to come into picture to make sure there is a data products and data platform is created, single source of truth is created, so that everybody can discover the data, everybody can hit the same source of truth, right? Which organizationally or horizontally you have created. We'll move to this slide. So this slide is talking about that. Why do we have this problem statement in itself is like kind of have taken a birth because there are multiple technical teams that you have in each of the units, right? So I'm a part of a intelligence unit where we have MLOps team as well, where we have analytics team as well, where we have business analysts, where we have data science community, where we have bunch of visualization folks, where we have bunch of data engineering folks as well, right? Now, because they all are tech sound guys, they all know how to do coding. They all are, I mean, when they are doing coding, they are hitting the databases, they are pulling a lot of data, churning a lot of data, creating analysis every day, right? But the problem is they are not talking to each other, right? All of these guys are like working in silos, and that's kind of a problem statement that's there. You will see in all the organizations, right? Everybody is like doing the work in the silos. Nobody is talking to each other. They all are at different tech teams, and in that same way, the data is siloed. There are multiple data assets are kind of eventually at the end of the day created, and this is where the problem is there, that why the data is so fragmented, so many copies of the same data is there. So with this we'll move to the next slide. All right, so this is from where we should start solutioning the data engineering pipelines, right? How do you first of all put lot of efforts to the business first, right? You understand the business first, and then you move on to the tech later, right? You build your tech later. You first of all understand the business. It should not be a case that you have built the tech first and then you are trying to adjust your business into it, right? So first of all, you should look at the business and then create a strategy that this is my business. This is how my business is going on. Every business has its own journey, right? You talk about any of the business, there is one starting point and then there is one ending point, right? And in between, it is generating millions of data, right? So how can you understand the journey of the data and you accordingly design your data engineering pipeline is what you should focus on. And that's exactly what we do in our organization, right? So after the business, the strategy for the data comes in, and then later on, once you have thought of a entire business, entire end-to-end journey of the generation of the data, and you have designed your strategy of the data, then I think every use case that later on has to happen can be driven out of that org level source of truth, right? So I'll talk about a bit of my organization's journey data, right? How in finance, I work for a NBFC, so I'm taking an example of loan journey. So how we understand our business first before getting into the tech and anything else, right? In entire lending journey, right? First of all, there is a loan application thing that comes into the picture. That's the starting point of our data, right? There is an application that comes in. There is a customer who has come to us, or maybe our branch guy have reached out to them to take the loan, right? Now, if you see, this is the starting point. There is lot of data that will get generated from the application form, right? Customer will maybe online fill the form, or maybe some physical form will be filled in. So that kind of goes into our application layer, right? Now, here, if you will use your data engineering concepts, right? The nature of the data at the application layer will always be a changing data, right? It is not like if today I have got a application, it's like in a created state. It will always remain in a created state. It will slowly move into created, in progress, then sanction, then approved, then you got as per the product, there will be different stages definitely, but then it has its journey, right? So it's moving data. Now, if you will have to consume this data, put it into your data lake, you will definitely look for a dimension kind of table that you will create out of it, right? You will not create a table which is just keeping the latest row of the data, right? you'll have to create a dimension table so that it is able to cover the entire journey of one loan application end to end, right? How it moved from one team to another team, because if you will see, in fact, the next stage is only talking about the underwriting. So if the first part is something which will be handled by the sales teams, right? There's a separate team, sales team. They will go to the customers, customer will reach out to them. They will create the application for that. Once the application and customer have come in, then they will move that application data to the credit underwriting team. Now, the credit underwriting team will do all that, they will try to figure out if the customer is a good or a bad customer. They will do entire underwriting process. They will see the documentation stuff, if it's a fraudulent customer or is it like a good customer. Now, when all of that stuff is happening in the credit underwriting, you can imagine the application from one team have moved to another team, right? So it is very important, right from there, by understanding the business, that how you will eventually keep designing your data pipelines, right? At each stage, how you will try to cover the entire business, entire area. So whosoever is touching the application, first of all, there is one guy, then second guy, then third guy. Everybody is doing something onto the application data. So accordingly, you will keep creating the data pipeline and a journey of that data, and accordingly you save it. Depends which data you will save it as a dimension, which data you will save it as a fact, right? You will use your concepts. Then it moves to finally the disbursement. So this entire is a loan journey. This another thing follows up to the earlier slide, is like once the customer you have disbursed, then it becomes your customer, right? Now, once it is your customer, then there will be a lot of every month transactions the customer will keep making to pay you the EMI. Now, if you will see that transaction data, that definitely automatically you will put it into a fact table data, right? That's how you will basically keep creating the journey at each of the stage. Once the customer have become your customer, he's gonna pay you EMIs every month. You're gonna put it into the fact data. Once the customer have become your customer, is paying you the EMIs, then the next stage in our business in finance comes is let's say if some customer misses to pay the EMI, then happens the bounces, right? Then happens the charges, check bounce or check bounce charges and all of that thing. Then once the bounces have happened, then comes to the next stage is how will you collect the money from the customer, right? Then there is altogether a different team, different domain. So now, with all of these two things, what I'm trying to explain is, this is how, first of all, you understand your business, right? You understand how my organization is kind of generating the data at each stage and at each step, right? And once you have a good hold of your business, then you make a strategy, and then you find out the skill set that you need to build your data pipeline. Straight away jumping to the tech stuff, okay, boss, we will use Iceberg, we'll use Snowflake or this or that, we'll use Spark or maybe SQL, whatever, right? Will not do the justice to the data that you have at the organization, right? So that's how we do. The entire journey is kind of covered. Now this is kind of blueprint of our entire. This is like bit technical slide. You guys must be able to relate with it. So this is where our journey of strategy of data starts, right? On the left-hand side, you see all the core application systems would be there. All the data, which is kind of your entire OLTP layer, right? Where the actual transactional systems are generating bunch of data, right? And why there are like multiple application systems that I explained earlier, right? There is one sales team, there is one credit underwriting team, one the customer have become your customer is doing the transactions, then there is a delinquency management system, then there is collection system. So you have multiple application systems, all of them are having the same file number data. It started with one file number, one loan number. That one loan number is like lying there in all the application systems. Some is just getting little filtered out, right? Some of the customers who got rejected will not move from LOS to LMS, but let's say a customer who have done the complete journey, become your customer, have bounced also, and you've done some collection also. that customer's data will be lying there in all the application systems, right? Now, once you have all these application systems on your left-hand side, you are creating a staging layer, data warehouse staging layer, which is what you call as a entire raw data lake, right? From that data lake, the core data engineering strategy of our data building, creating our data products starts, right? Now from there, we, kind of use all the ETL tools. Now here is where we can talk about bit of a tech stuff, right? How or which tool stack we use. The tool stack that I have shown there is what we are using currently. We're completely on AWS, and this is mostly the tool stack that we are using to build our data products, right? There are kind of dependent on the use case, right? We are creating either a real-time or a batch pipelines. Many people are kind of creating the real-time pipelines to put the data onto the MIS, which will be seen by people monthly once, right? Which does not make sense. I strongly feel you only do a real-time use case of a data where there is no storage, right? You pick up from the application system when some action happens, you take that event, you process it, and you give again somebody to take the action because this event have happened, right? So creating a real-time pipeline to put the data into some database or maybe to put the data into some visualization or a MIS makes little less sense to us. We are only doing the real-time use cases in our digital lending journey, where let's say a customer is doing a loan journey and he kind of did some 5-6 stages, and maybe it's because of network blip or anything, he kind of got dropped off from the journey, right? Now he's not there in the journey anymore, right? So we take that real-time events, we bring that data into the layer, we do some transformation, and straight away push it to the WhatsApp channel or to the call center, right? Now that's where the real-time pipeline makes sense because you are giving directly to somebody who's taking the action on it, right? It's not like you're taking a real-time data, you're putting a lot of effort to put up a real-time pipeline and put the data into the database. Now, once the data query and ETL work have happened in that box, that is the same data, same source of truth, which will be used by business analyst, data science team, MIS team, and a GenAI team, right? Nowadays, we all are like doing GenAI. We're living in a world now where GenAI have come into picture. So I'll tell you one thing. When some time back, when I was young, when I was like, 25 years old, the NLP kind of models came in, right? And we were like, every one of us was like, wow, NLP aa gaya now. Seems like generations mein NLP hi hoga. Sare bots isi se hi banenge, right? But I think very soon the new tech came in, right? And NLP, aaj ki date mein nobody is using NLP, right? The same, I love GenAI, not like I don't love GenAI, but then the same thing is happening with the GenAI now, right? Currently we are in a place where we are seeing sirf GenAI hi hoga, everything will happen in GenAI, but nobody have seen the entire cycle yet. It is just the beginning, right? But let's see where it takes us, right? Definitely it has like lot of power, absolutely lot of power, but let's see where it takes us. But I'm still curious to see the entire cycle, right? Where in GenAI we have built something, we have lived with it for some time, it have gone down, and then we have again fixed it with the GenAI, and then again have deployed it into the production. Is what that entire cycle is what I'm still to see, right? Still GenAI is like being done by hands-on. I mean, there are folks who are doing the GenAI, they are doing some manual stuff in that to make sure the GenAI works the way we want it to work. But then let's see, once that entire cycle happens in the next couple of years and we are able to see the real value of the GenAI. But the point here is that the data products that you will create, I'll just convert the same slide into the business thing that I have talked about earlier, right? Which helps us to, make sure we are creating a org level data and we are creating a single source of truth for, the organization. I have converted now the same slide into the domain specific stuff that we do, right? When I have talked about the entire loan journey stuff with you guys, right? I mentioned that how I will design my data warehouse from the data lake, right? This is how we do it, right? In the loan journey, the first thing is happening is the sales, right? So the sales dimension is there. Then later on, there is a credit underwriting happening. So the credit domain is there. Credit data product has been created. In the next thing, the happening is the ops team, operations team mostly is the team who's responsible to do the disbursement to the customer, right? So when the data have moved to the next layer, it's like the operations team. So operations layer you will have created. So this is how you will design your data marting and your data layer, right? How will you call out the different data products? You try to keep all the attributes and the variables around that domain into a single layer or maybe a bunch of tables so that the business use cases later on will not have any struggle, right? When you have covered the domain, you have covered the entire data into and you have put it into a data product. Obviously, all the use cases that particular team would want, you will be able to serve with your data product, right? I'm just digging deep into what I have shown earlier. This is bit granular thing that we do, right? How do we design our pipelines? So all the source systems and the data lake thing, that's there. You've seen in the earlier slide, right? So all the data that comes in, you call out. So data lake here is like your raw data. Then you move on to the data marts, where domain specific you are creating the data marting. You'll use your tech, whatever tech stack you want to use, you will use your tech stack. After the domain specific data marts or data products, once you have built, you have created, you will create a aggregate layers on top of it, which you call L1, L2, L3 type of layer, right? So in every organizations, you guys will have to, create a lot of KPIs, right? At a different level. Different team wants to see the data in a different way, right? Somebody wants to see at a India level, somebody wants to see at a zone level, somebody wants to see geography level, somebody wants to see at a employee level, somebody wants to see the granular data, right? So this is the strategy that we follow. That first of all, we bring in all the raw data into the lake, then we create data products domain specifically, and then later on from that domain specifically, all those data products gets joined with each other to create the KPIs, different KPIs that everybody wants to see, do the work accordingly. So we do that aggregate layer creation later on, and once that aggregate layer is created, that gets consumed into multiple products and applications, right? This slide will come to this maybe later. I'll first of all jump onto this slide, which talks about how we are trying to transform our data engineering. So till now we kind of talked about bit of a stuff which is like how you are designing your data engineering pipeline, looking at your business, right? This one talks about bit more how you are scaling it to a level so that you are using the right tech stack, and you are able to handle the load. You are able to handle the new products coming in. You are able to handle the data volume as it is growing. You are able to handle the products that are consuming your data, because products needs are kind of growing every day. So you need to make sure your architecture that you have designed is like able to scale in a way so that you're able to add in more and more data pipelines into it. You're able to create more and more KPIs. You're able to handle the volume of the data. So here in this slide, you see mostly the blueprint thing. There are source systems, ETL. There are two types of pipelines that I've already mentioned we're trying to create. One is the real-time pipelines. One is batch pipelines. The aggregate layer that I talked about in the earlier slide, the one thing that we do in the aggregate layer is I mean, you must have heard the microservices architecture in the software engineering, but kind of similar thing we are trying to do. In fact, we have done that in our data engineering world as well, right? So the moment the data products are created, right, there are like different KPIs are kind of created in a procedural way, and all of those procedural KPIs kind of work in the moment your data product is refreshed, all of those KPIs kind of gets kicked off in a microservices way, right? For example, let's say you have kind of created a sales data mart, and in the sales data mart, definitely you'll have the application count, how many folks have kind of got sanctioned, what was the sanctioned amount, and if you have to create an aggregate layer on top of it, what will you do? You will, write one aggregate code which is doing the count of file numbers, the count of applications which got sanctioned by putting a where condition, and you will do the count of, or maybe sum of the sanctioned amount as well, right? So you probably will do that in one, you will do that on a relational table, and you do that query as a single query. In a single query, you can aggregate all of these together, and then you'll put it into a relational table again, right? What we try now with this, the problem statement that we were having earlier was, let's say there was some issue with because source data is like pretty volatile, right? In the software engineering team, which is front-ending the customer, and they work together in a very coupled way with the product teams, and they build new journey steps every now and then, and they are building the new products as well, right? We are at a downstream. Many a times we would not know what is going to come into the pipeline, right? Now, let's say sanctioned amount column have kind of changed, right? And our downstream pipeline and a lineage couldn't, create a alert for us that sanction amount have changed. Now, if you have done an aggregate layer in a single query, right, the count of file number and sanctioned count will work as a query, but the amount will go for a toss. Now, with this one single query in the aggregate layer, you were creating 3 KPIs, right? The number of applications, how many cases are sanctioned, and what is the total amount that you have sanctioned. Now, if you have done that in a single query, because of just one column, all the KPIs will go for a toss, and you will not be able to publish onto any of the product. So what we do, we follow a different strategy. We do it in a microservices way. Our each KPI is kind of, we are now migrating to Kubernetes. We are containerizing all of these KPIs and procedures individually. The moment the sales data mart is kind of refreshed, it will hit all the microservices, all the KPIs together. They will run in a microservices parallel way, and all the KPIs will get individually created, and they will get into schema-less table. Earlier, we were like keeping it all in the relational table. Now, the problem with the relational table was that we will not be able to, if one goes down, everything goes down, right? Now, we are putting the target data into a schema-less, only the aggregate layer, not the data mart, because putting the entire data mart into a schema-less does not make sense. So only the KPIs, we put it into, all these attributes that we have created, they work in a microservices way. All of them will be created parallelly. And that's how we are able to, and one another thing that we were facing, right, as the organization was growing, the number of products were growing, the number of, attributes are getting added every day, right? The aggregation queries were like kind of becoming big and big, right? And if in one query you are doing tens of sum queries, tens of count queries. There are multiple columns that are going into the group by condition. Your query very soon will start becoming a pain for you guys, right? So that's why doing it in a this way have kind of really helped us, where we are able to now scale on the KPIs. One KPI does not hamper the other KPI, and the products that are kind of consuming the data at the downstream are not getting. So that's what we have done technically. Now, in this entire thing, the earlier slide basically talks about the reusable products. How we can create a reusable stuff, so that you are enabling everybody in the organization to build their data products in a same fashion. So this reusable thing that we are trying to do, this is also kind of explained in this one. If you see at the bottom, right, there is kind of schema registry thing. Entire ETLs are managed by that. Metadata functionalities are created. CI/CD pipeline is created, right? The common VPC policies and networking is kind of created for all the jobs, right? So all of these are like kind of parameterized stuff, right? Anyone who wants to build an ETL pipeline can just reuse these components and will only have to do just the code, right? To do the aggregation or maybe the data marting stuff. Now I'll talk a bit about how our world also is getting, entering into, my world is also entering into the Gen AI stuff, right? So after doing all of this data product stuff, right, you have built the multiple data products. You have kind of managed them very well, how you want to manage them. How now you can expose them and create an experience of, Gen AI, right? So we have multiple Gen AI agents that we are creating, right? We are from these data products that we have built earlier are kind of exposed through Gen AI, and bots are created. We have a goal that we want to create a AI assistant for each of the job function. Now, because for each of the job function we have created the data product, putting a Gen AI on top of it becomes very easy, right? So this is the common agentic framework that we are using to expose our entire data products to the users, right? So we have like assistant in current day. We have an assistant for the sales team. We have an assistant for the HR team. We have an assistant for the credit underwriting team. Couple of agents are under development. We are also creating an agent for the FCU team, fraud team. We are also creating an agent for the operations team, right? But couple of agents are already live, which are working well. The another thing or a challenge I must say we are facing is, with this Gen AI, lot of data you have to expose to OpenAI, right? And looking at we are kind of RBI regulated organization, right? So putting entire data to Gen AI, exposing entire thing to it is also a bit of a challenge. It's not like straightforward. So we are trying to do a lot of anonymization of the data, trying to create a decoupled front end where your encryption can come into picture and keys are only with the front end application system, and the in between Gen AI layer which have been used is not exposed directly to the data. Through the Gen AI, we are mostly kind of exposing the aggregate layers. There are very little use cases where we have given a granular data, which is like not having anything to do with the PII or a SPDI data, right? For example, if it's a HR domain data, we have kind of exposed that just to say how many leaves I have, where can I find my letter, where can I find my Form 16, all of that stuff. In HR domain, we have done that, right? The last thing that I want to talk about is the governance that we have set up for done. All right. So this is basically the governance principles that we are using. Very simple principles that we use. We put a lot of effort to do the governance. The only thing that we are trying to do is, first of all, the first principle is how you can make sure you know what you have built, right? and once it's running in a production grade stuff, anyone in the organization can find out who have built that asset, how it is running, where it is running, and if I have to reach out to someone, how can I reach out to the one who have built it, which team is the owner. So we have simply created a concept of know your data assets, right? Then control over data accessibility is like a lot of admin stuff we have done, some custom stuff also we have done. Data dictionary, okay, so I'll skip to the last thing. Data lineage, right? In the data lineage, we are again using Gen AI now to create the entire lineage. So we have created an AI assistant for our team as well, right? Every year there are like bunch of folks that we hire from the colleges, campuses, whenever they join. It's very difficult for them. It takes like couple of months for them to onboard it with the data that's been created in the organization from last few years, right? So we have created an AI assistant for our entire unit as well, where all of our data lineage, data products, table names, column definitions, data dictionary stuff is kind of exposed to bot, and that bot is being leveraged by us. And I'll tell you, only this governance principles have kind of helped us to build that bot, right? Otherwise, if you don't have that governance set up, you will never be able to do that. Now, that same AI assistant is also enabling the AI-based coding for all of us. Basically, if I ask Gen AI today how I can create a SQL query to join two tables, it will give you a blank table name and all of that. But the bot that we have created on top of our governance, it will give you exactly the tables that we have in our know your data assets, right? If I'll ask a question that how can I get a last 6 months applications data, so the Gen AI will give me a query for my applications table, right? And the Gen AI knows it's a SED2 table. I'll have to create what type of where or a condition I have to create. So it creates exactly the same query, which can be readily used. You just have to copy paste the query and run it into the IDE. Yeah. So yeah, a lot of effort we have put onto the governance as well. Thank you so much.
Thank you so much, Mr. Jagru. We will proceed for lunch, everybody. The next session starts at 1:45, so make sure you're here by 1:40. And thank you. Have a great lunch. Thank you.
To strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger gene. The Tiger gene is what makes us learn relentlessly, experiment without fear, seek help and offer help. The Tiger gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity and optimizing every step of the process.
AI Run. It really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
Fit clearer requirements help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained Gen AI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product. It doesn't replace real humans, but allows us to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name. AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, producing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
you tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes. 3. Observe the data and the system in production. With IceDQ's unified data reliability platform, automate data testing, automate data monitoring, implement data observability. IceDQ, data reliability engineered.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and with tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of Mathco. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligned with our larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale Mathco from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Until recently, AI was a field for specialists, scientists, experts. An amazing technology, but so complex only a few people could use it. Well, that doesn't fly with Snowflake. Since the day we were founded, we've made it easy for all types of people to work with all types of data. And today, we're applying that can-do, let's-do, will-do attitude to AI. We're eliminating complexity. Simplify, simplify, simplify. And putting the power of AI into the hands of everyone. The era of enterprise AI is here. It's easy, efficient, and trusted. Right now, thousands of organizations around the world are driving success in the AI data cloud. Join us, and let's put AI to work for you.
In a world clouded with complexity and ambiguity, there exist significant opportunities for disruption and growth. At Tiger Analytics, we help our clients navigate this uncertainty, empowering them to move decisively through shifting sands, unlocking these opportunities. We work with our clients to strategize, design, and engineer a future-ready enterprise. At Tiger Analytics, we've been reimagining possibilities with cutting-edge AI and analytics, solving some of the toughest problems out there and building the blueprint for tomorrow. And at the heart of this mission is our battle-tested team of exceptional technologists and consultants. It's our unique expertise and character that enable us to create exceptional value even in hazy conditions. That's our Tiger Gene. The Tiger Gene is what makes us learn relentlessly, experiment without fear, seek help, and offer help. The Tiger Gene is what helps us uncomplicate complex problems, build for the future, deliver clarity amidst ambiguity. To our clients who are traversing a fog of uncertainty, we are not just a technology partner, we are a certainty partner, relentlessly seeking, solving, challenging, and growing. Together, as we set bold ambitions and target extraordinary outcomes, let us experience the power of data-guided decisions, the potential of connected insights, the promise of an AI-empowered future. Experience certainty to shape a better tomorrow with Tiger Analytics.
AI is changing the world around us, and the complex world of software development is no exception. EPAM AI Run is transforming the entire development lifecycle, not just by generating code, but in supporting multidisciplinary teams, boosting enterprise-wide productivity, and optimizing every step of the process.
AI Run, it really helps us accelerate product ideation. It helps us arrive at new product hypotheses more quickly.
You can validate your hypothesis faster in production.
Writing test cases.
Fit keynote requirements help us align our product roadmaps.
Instant market research.
To create stories.
For rapid and collaborative business case development.
AI Run drives a first-time right approach, boosting speed, productivity, and quality, from project onboarding to product deployment, with an ecosystem of trained Gen AI agents that unlock next-level collaboration. It's a natural evolution for one of the world's leading engineering and innovation organizations.
At EPAM, we have been delivering tech-enabled solutions for leading global enterprises for over 3 decades. Over the last decade, our AI capabilities have accelerated from early apps and code generation to enhancing the efficiency across the entire SDLC.
All the silos that were existed in the form of ticket passing back and forth is gone.
It's a better quality product, it's faster product. It doesn't replace real humans, but allows to do better our research work.
With a superior quality product at a 30% faster time to market, AI Run delivers instant ROI.
It's kind of in the name, AI Run.
We're revolutionizing the way we deliver digital products with EPAM AI Run. The future made real.
By 2025, enterprise spending in Gen AI will soar by 50%. And it's not just statistics, it's actually call for all of us. And we're already helping many organizations create the value by reshaping customer experience, by generating the content in every medium, by automating innovation, by improving demand planning, and also streamlining many different data and business processes.
Traditionally, large language models operate in zero-shot mode, reducing output token by token without revisiting or refining their work, much like writing an essay in one go without any revisions. While impressive, this method has its limitations in achieving top-tier quality. Agent workflows address this by introducing an iterative process, enabling LLMs to refine their outputs.
Are you tired of using the same data quality approach without seeing improvements? Remember, the root cause of 80% of data issues come from development, 15% from operations, and less than 5% from the data itself. Think of your data system as a data factory. Implement data reliability engineering. 1. Implement data testing during development. 2. Monitor your data processes. 3. Observe the data and the system in production. With IceDQ's unified data reliability platform, automate data testing, automate data monitoring, implement data observability. IceDQ, data reliability engineered.
Mathco began with a bold yet simple vision in 2016 to help enterprises unlock the full potential of their data and solve their most pressing challenges. We started as a small, passionate team of problem solvers, driven by the belief that data could empower businesses to think bigger and do better on their own. Self-sufficiency remains at the core of our offerings to enterprises. We strongly believe that we live in an age of hyper-personalization. Enterprises, in the quest for being digitally at the top of their game, often face critical challenges. Challenges that can result in millions of dollars lost or missed opportunities to earn them. They're looking to evolve while overcoming their own unique set of challenges.
We today engage with more than 60 plus global enterprises across multiple verticals like retail, consumer goods, pharma, technology, and many more to come.
We're here to enable them to make smarter, faster decisions with enterprise intelligence. It's not just about solving problems, it's about building trust both with people and the tech and creating everlasting value.
Our strength doesn't just lie in numbers, it's in the unparalleled expertise of our mathematicians. Our people are the heartbeat of MathCo. They innovate, collaborate, and bring ideas to life in ways that drive real-world outcomes.
Every individual has a space to take ownership, make an impact, and shape not just their careers, but the success stories of our clients.
Everything we do revolves around creating meaningful experiences, whether it's through exceptional delivery for our clients or the way we collaborate and support one another as a team.
Each mathematician's goal aligns with a larger mission to empower decision makers in global enterprises to own and activate intelligence.
Our goal is to scale MathCo from where we are to 10 times our size. 10x in terms of the value that we add to our customers, the quality of experts we have on board, and the capabilities that we invest in. All in all, we want to be a one-stop shop for all our customers' digital transformation needs.
Until recently, AI was a field for specialists, scientists, experts. An amazing technology, but so complex only a few people could use it. Well, that doesn't fly with Snowflake. Since the day we were founded, we've made it easy for all types of people to work with all types of data. And today, we're applying that can-do, let's-do, will-do attitude to AI. We're eliminating complexity. Simplify, simplify, simplify. And putting the power of AI into the hands of everyone. The era of enterprise AI is here. It's easy, efficient, and trusted. Right now, thousands of organizations around the world are driving success in the AI data cloud. Join us, and let's put AI to work for you.
Hello, hello. Okay, hi everyone, welcome back. I would request if you could take the seats in front and just sort of fill up the space here. People at the back, there, and even there. Guys, come on, get up, come in front. Okay, okay, all right. Yeah, hi, welcome back. Before we begin with the next session, we'll just have a short video play for us, and then we'll proceed with the next session.
From cave walls to phone calls, we've always wanted one thing: to connect. Over time, how we connect has changed. It got faster, smarter, and bigger. From cave walls to phone calls, we've always wanted one thing: to connect. Over time, how we connect has changed. It got faster, smarter, and bigger. Now it's not just people talking to each other. It's machines, apps, systems, all talking through data. And at the heart of it all, data engineers, building the roads that keep this new world running. Data and AI are helping us live better, work faster, and solve big problems. This is just the beginning. Welcome to DES 2025.
Okay, so up next we have, we will turn our focus to resilient data architectures, a must-have for businesses that demand uptime, speed, and adaptability. This session dives into designing fault-tolerant, scalable data systems using distributed computing, cloud-native technologies, and smart disaster recovery strategies. You'll walk away with practical insights on building ecosystems that can withstand disruption while ensuring performance and continuity. Guiding us is Biro Kumar, Technical Advisor at Better Half and co-founder and CEO of Limpio. With deep expertise building high availability systems at scale, from Hansel.io to Lido, Biro brings a wealth of knowledge in distributed architectures and AI-driven automation. Let's give him a warm welcome.
Thank you so much for having me here. Am I audible? Yeah, perfect. Also, thank you so much for coming here. I hope you had a good lunch. So, before jumping into that, let me give you a brief introduction about myself. My name is Viru. I'm a co-founder and CEO of Limpio. It's a visitor management system where we provide a very seamless visitor entry to the gated premises. So it's an earlier stage startup. Beside that, I'm also a technical advisor at Better Half. Now it has been renamed to the wedding company. So, so before we move further, I'll say how many of you are engineer? I think I don't know the audience. How many of you engineer and DevOps? Could you please raise your hand or something? Most of them are right? So we talk about resilience. Could you please tell me why do we need resilience system? What is the purpose of having a resilient system? Anyone? Like we build a system. I think most of them are, let's say if I talk about from the startup perspective, do you think we need a resilient system for a startup? Anyone? Okay, so for a startup, right now, we don't need that much resilient. What we focus is on mostly on the functionality should work fine. That's all we focus. But as we start growing further, we start, the startup start becoming bigger company. It is very essential for us to have a resilient system. Why? Because I think recently I think couple of months back, we got to know that, okay, the UPI was not working. Because, see, the system was not that much resilient. It was couple of hours the system was down. And the second, if I talk about, there is another thing happened last year. There is a CrowdStrike, a company called CrowdStrike. There was some kind of problem happened in that. And because of that, lots of, I think, more than hundreds of planes were grounded. They couldn't fly. Company lost more than $500 million in that, whatever the problem that happened in that outage. And the reason is, again, the system was not resilient. Can we make a system resilient, 100% resilient? No, we can't make a system 100% resilient. System is doomed to fall. Any system, whatever system we make, they have to fall sooner or later, right? But the problem is not about that, okay, system will fall, right? It has to fall. But how we can make a system which can create a lesser number of impact. Let's say I talk about UPI, right? Or like, I'll give you an example of Netflix. Imagine a Netflix system which was, the video upload is not happening. Let's say movie is not getting uploaded in Netflix. But Netflix can still work, right? I can still watch the video, like, so the read quality and the Netflix will work fine. At the same time, I can still watch the Netflix with the lower quality of video. So when we talk about resilience, this is what it's basically we are going to talk about. That system will fail, but it will not create a complete outage for the system. Like we saw in case of UPI, we saw in case of CrowdStrike and all the thing. If the system has had to be a high resilient system, the problem would not have happened that big, large scale. The problem would have happened, but it could have been contained till a certain point. Why should we focus is whenever this kind of problem happens, as I mentioned, the company loses millions of dollars. There was a Facebook outage happened in 2021 where Facebook was down for a couple of hours. There was some bug there, and because of that, they lost around, I think, $300 million revenue, the ad revenue. Also, the reputation takes a hit. So it's very important that our system should be, resilient. Now, 10 years back, this might not be that big issue, but now it has become a very big issue. This user expectation arising. There is a case study was done by AWS where it was told that in Amazon website, that whenever there is a 100 millisecond delay happens, their sales gets down by 1%. So they have come up with that. Similarly, when 200 millisecond latency gets added into the Google, the searches of the Google has gone down. So this kind of things, since user expectation rising, it's very important that we need to know that, okay, if system is working, how far the system is responding, how much time is taking. If we add some kind of delay, what exactly is going to happen? So today we are going to talk about certain thing. We are going to talk about how we can make a system as an architecture resilient. What is the fault tolerant system, right? Technology and some architecture pattern we'll see, and we'll see a real world case study. Given how much time is permitted, we have a 30 minutes time, we'll see how much we can cover in that. Okay? So when we say resilient architecture, right? So as I mentioned, the system has to be failed. No system is failed. Every day Netflix fail. They have thousands of microservices every day. Not a single day when Netflix says they don't fail. They fail. It doesn't mean that the system is totally down. Since they are used the thousands of microservices, I have closely worked with the Netflix team and all. So I know their system. But every day they deploy some of the microservices. They keep deploying that, and there are certain problems happen. But they keep fixing that. We as a user never get to know. Why? Because system has an auto recovering mode. So a system fails, but system detect there is some problem. System automatically basically fix those issues. How do they do that? Something will also cover that. Mostly there is a one thing, very easy way we do that always in a, let's say when we use AWS or something, we see the auto scaling, right? So whenever there is a spike, surges happen, some of the requests gets dropped, but because of auto scaling, some auto recovery also happen with that. Zero downtime experience, is it possible? If you see, that is not possible. No system can claim that's a zero downtime experience. It is, again, as I mentioned, it's for us, we don't see that, this kind of problem from our side, right? But this keep happening. Zero downtime is a myth, it does not happen. These are the, again, best resilience system as I talk about. Netflix is a very good, very, very high resilient system. Swift, how many of you know about Swift? Swift, you know something? Okay, Swift is a bank, right, where all the transaction, the intercontinent or the country-wise transaction happens. One of the very high resilient system, handle more than millions of requests per second, something like that. S3 is again a very good resilient system, also very high durability, talk about 11.9 and 11.9 as such. Beside that, there are other resilient system I talk about, like our stock exchange. It's a very high resilient system. Have you ever seen stock exchange getting down or something, right? Generally, it definitely happens sometime, but again, it is not visible to us. I think couple of months, we must, if someone uses stock exchange here, I think we heard that stock exchange was open on Saturday. Do you remember? There was a, right? Because they were testing exactly the resilient system. They were testing if the disaster recovery things work or not. So again, this kind of things keep happening. Some, again, as mentioned, for the entire day that I remember, stock exchange was open on Saturday just to test if disaster recovery system worked for them or not. So again, whenever we say the resilience, there are certain things comes in our mind. What comes, like, we always get confused at what is the meaning of resilience. We think, okay, if infrastructure is good enough, that means system is high resilient. But it's not about infrastructure, right? It is about multiple things, right? Infrastructure, obviously, it's a very important thing. Or the infrastructure should be multiple region, multiple country, so that the data could be replicated. So infrastructure level is there. Other thing, when we talk about resilience, your application should be resilient. Means your application should have the redundancy. You need to have multiple application copy running at the same level in a stateless mode, mostly. Then we talk about data layer. So database also should be replicated to multiple places, right? So data level resiliency is also important. Another thing is monitoring. Again, we generally overlook the monitoring part, right? How monitoring helps in the to make system resilient. So I'll tell you example. In 2016, I was working in movie at that time. I then quit the company and joined as a founding member in 2015, a company called Hansel. So we used to fix a real-time bugs in the app at that time. So you don't need to release a new version of app all the time. Okay, come to our dashboard. We'll provide a dashboard. You can fix your bug, and your app will get fixed within 15 minutes. Okay. So that's something we had built that time, and it was an instant hit. We call it stability. And every company, talk about Tokopedia, Paytm, at that time Fresh Menu was growing very fast. So Fresh Menu, these are the cult fit. This company was using our system. So because of the demonetization happened, the Paytm request shot up like anything. Like our system was 1 year old. Our system was not that good right now. We were just working on that. And because of Paytm request has gone so much that our system was not able to, to basically take that load. So Paytm, at that time, the Paytm system was not that good. Like there was so much problem the Paytm had. One of the problem Paytm did that at that time they were using wallet. There was no UPI at that time. So mostly you transfer the money into the wallet and then use that. And if you transfer wallet money back to the bank, they charge some certain amount. So they were charging around 2.5%. So Paytm released their app, mentioned 0.25%. They made this blunder that rather than 2.5%, they mentioned that 0.25% charges they need to pay. They realized that and they fixed that issue. But since our system was not working, they couldn't fix in the real time. So if they go with the existing conventional way, it will take them to fix it 3 to 4 days. They will need to fix the bug, they need to test it, they will submit to the Play Store, App Store, and after the approval, they can release in a role-wise basis. So they told us that our system is not working. And we again fixed that our side. It took us a couple of hours for us to fix all those issues from our end. So had our system as a very good monitoring as such, we could not have faced that problem. So as again your company start growing up, monitoring is the most important thing. We generally in India overlook the monitoring part. So if you have a good monitoring system, you can figure out, even your client tell you, right? When client tell you that okay, system is not working, it's not a good situation, right? We always feel not good in that case. So I would say monitoring, whatever monitoring you use, whether you use Grafana or something, system level monitoring, application performance management, but please do that. And the most important thing in a resilience checklist is a human. Because we human are the one who makes the mistake the most. We generally again overlook here, okay? We think that, okay, infrastructure is fault tolerant, application layer we use ELV or whatever, data layer is that we are replicating, but human are the most, is the one which makes the most mistake. In each organization, what we do is we always make sure that, okay, there is one person who knows everything in organization, who knows how to deploy in production. What if the person falls sick? Do we have any kind of redundancy? Do we have any other person who has the understanding of the system also? So it's very important that the person should go for a leave, other person should take responsibility and see that in case of any problem happens, like system goes down, if that person can handle the system or not. So what are the challenges we face basically when we talk about resilience? Why is that so critical, and what are the problems we face? So one is about, as per the CAP theorem, we know that if there is a partition is there, either you go with the consistency and availability, so that is there. The other problem is if you have come up with a data ingestion layer, like last speaker was talking about, a lot of layer as such. If there is any, it could break in at any places. If you have a good observation, good monitoring system, then only you will get to know where the problem is. If you don't have good monitoring system, you will never get to. You will get to know, but it will take a lot of time. Again, there is a third-party dependency. Every system, whatever system we use, we can say that we use, let's say, just pay, razor pay, right? We use for analytics, we use, I would say, mixed panel, clever tap. If those system goes down, how will you make sure your system is resilient? Whatever the code we write, again, the human comes into the picture, schema breaks if the code is not written correctly. Again, lack of visibility, as I mentioned about the monitoring. So it's very important. So because of that, the challenges in resilience is high. How can we make our system resilience a very high resilience system is, again, if your system has redundancy, it's a very important. I think all of you know what is redundancy, so I'm not going into that. Loose coupling, if your system is a loose coupling system, it's important. Graceful degradation, as I mentioned, right? If your system outage happens, your system does not go shut down. Your system's small part should, go shut down or something like that. Or it should work with a limited capacity. It should not that, it should completely break down. Fault tolerance, if you are making a fault tolerance, again, it's a derived version of redundancy. If you have a redundancy and if you have a good way to manage the fault tolerance, you can do that. Observability, as I mentioned, is a very important part. And as you scale, scalability also matters. Now, when we say availability, right? When we say our system is available for 99% time, what does it mean? It means that in a year, 3 days, our system does not work. When we say 99.9%, means 39. We say in a year, our system is 8 hours not working. Similarly, for 6/9, your system is downtime for 31 seconds. Again, no system is 100% available. No system in the world could be considered 100% available, right? How can we increase the availability, right? How can we increase the availability, right? So this is a system here where there is a one more system is added. It's a kind of redundancy we talked about. If we have this kind of thing, if we have a single component and the availability of that system is 99%, if we have two like parallel system where the two component is there, your 99% goes up to 99.9%. If you have a 3 system in parallel, you have a 6/9. So if you had just redundancy here, your availability will go up, right? So okay, let me ask one question here. Let's say you build a system, and your system is, you need a, let's say, 2 CPU and 2 GB system, right? Will you prefer to choose one server of 2 CPU or 2 GB, or will you prefer to have 2 server, 1 CPU, 1 GB each? Which will you prefer? What is the reason? Sorry? Fault tolerance, perfect, right? So exactly the fault tolerance, it will increase your availability. Again, if your system goes down, not all the requests will be lost, right? Let's say if I retry, might be the request will go to that system, and then it will work fine, right? But the problem is that if your system is will come later, that if you use 2 of these, let's say 1 core, 2 core as such, but if the system is not able to handle, then problem is a cascading effect will come into the picture. So we need to also focus on how we can manage the cascading effect, because your system 50% chances will system work, but 100% request will come to that machine, and if your machine is not capable of handling 100%, 50% only, that machine will also goes down. So we need to manage that too. So when we say high availability strategy, how we can do that? We need to replicate our system into the multiple region. Replication is important, but we need to make sure the replication happens not to one in zone, but it happens to the multiple region as such, right? It's very important. Imagine there is a India-Pakistan war happened, and they bombed one of our data center. Let's say we are using AWS or GCP. One of data center goes down, and if our data is there only in the same availability zone, even if you have a replication, your system is no longer high available. Your system, you will be out of the business, right? So second is apply failover routing. So let's say generally when you build a system, whether you use ELV, right? You use ELV, then you use multiple server behind it. What if your ELV fails? What will you do? Is that something we do that? Because that is also possible, right? ELV could fail, and it keeps failing though. So it's very important, again, so it's very important that you need to have multiple ELV as such, not a one ELV, multiple location, that one in, let's say, Mumbai, one is Bangalore or something like that. And there is a simple routing structure is there. You can have a weighted routing where request could go from one ELV to another ELV. DNS provide that. So it's very important. We should also use multiple ELV if you really want to increase the high resilience of system. If one ELV goes down, then request should not fail. It might add certain delay because that ELV is in some other location, but it should keep working. Health check and auto healing. Again, it's a kind of auto scaling which we keep doing that. And as much as possible, make sure that always use some kind of managed services, which I think everyone here must be using some kind of managed services, whether it's AWS, GCP, Azure, or some other, rather than using on-prem, because then that creates a problem. If you use on-prem, then you need to manage all this thing on your own. So that is there. Other, as I mentioned about, right, the dominoes effect, right? Again, there are two kind of dominoes effect happen. One is horizontal level, one is vertical level. When we say horizontal level means there is a ELV and there are multiple server you are using behind it. And if imagine that one of the server goes down, or if there is certain a spike happen in your request, one server will go down, and because other server is not able to handle those many requests, your entire system will go down. That is a horizontal level dominoes effect, right? And because of that, what happen is that you need to have certain kind of resiliency. So make sure either you can use rate limit, something to make sure that each server can handle only this many requests. That is the thing. Second is vertical means if you have a data ingestion layer, let's say you are using connection or database at the end of that date, and you are having everything in a tightly coupled things, like one server is making request to downstream to another server is making request downstream to another server. If one server, let's say you are using database, you have a certain number of connection pool, all of the connection pool are busy. What will happen in that case? Requests are coming to your system, but you are not able to handle those requests. So because of your downstream is not able to handle those many requests, your upstream server will start getting panicked, and they'll start either dropping the request, or they will also goes down because all the thread connections are busy. So for that, it's very important to use event-driven architecture wherever it's possible. Again, in not all the cases, let's say in banking system, that is not possible. But wherever we talk about eventual consistency, it's very important to use event-driven architecture. And there you can use certain kind of queue. It also help you to, if there is any sudden kind of surge happen, the system should handle that. So that is the thing. Now, another thing, whatever we talk about, okay, we need to make all the system, resilient as such. But another important thing is disaster recovery. How many of us here has ever recovered database in production? Any guys? Okay, you have done, right? So, but generally what we do, build the system, we take a snapshot, we replicate that to another region, right? But generally what we do, we don't, I think there are very few people I have done that, but I have seen in my organization, no one has done that. Because generally, this is a very extreme scenario happen, but sooner or later, this will happen. That's the question here is whether this is gonna happen or not. This gonna happen, it matters at what time happen. If it happens when your organization is very, thriving a lot, at that time it happens. And if you don't know, and you are the one who is responsible for that, then this is a problem. So disaster recovery is very important. We should at least try it out. It's not that different, but actually what happens is when you are in panic situation and when you do that, you make a mistake because at that time the mind does not work. The bosses will come to you, will start pondering that, okay, this many things happen. So it's important to at least try it out, okay? This is what exactly it's talk about, right? Disaster recovery as such. So there are two kind of disaster recovery generally. One is about natural disaster. We know that, okay, if natural disaster happen, we all know that, okay, go to the AWS, keep making a snapshot, okay, and recover from a certain, whatever the recover last time you have taken snapshot, recover from that. There are other kind of disaster happen when there is a cyber attack happen. Let's say some hackers come and they destroy, like they either stole your data or they corrupt your data. That recovery is a very difficult because the hacker might provide some kind of virus, some kind of anomaly in your data. So you need to check, is that any kind of problem happen in the data which has been already compromised. So those recovery is a different kind of recovery that needs different kind of expertise. So that is again a recovery, but again, that is a different topic. So you can check yourself where your resilient maturity, where do you stand, right? What we talk about, a system where there is no backup, all the thing manual fixes, these are the different level of resilient, okay? You can consider yourself where your system basically stand. Whether your system stand is a fragile, you don't have any backup. Generally, I think a startup works from that perspective, which is totally fine. But as you move to the ladder, there are different kind of that. Again, we talk about fragile, basic fault tolerance, automated recovery. I think till 3, graceful degradation, we need to focus on that as we start moving further. Beside that, later we can add more expertise as such. I think over the time, the AI-driven detection and recovery is going to take a shape as such. So I think that is important. In future, everything is going to cover through AI. So this is again a pattern. You can use circuit breaker pattern. You can use back off. So whatever I talked about from the system level. I didn't talk about what if the request starts going up a lot, how can you handle? So you can use either circuit breaker pattern, you can use the retry timeout as such, that okay, how much, if there is a request comes, if request fails, you add a retry mechanism, make sure you add the exponential timeout there, that 1 second, 2 second, 4 second, and make sure you also use the write ahead log books, so that if there is any problem happens, you know exactly from where you need to recover your data. So that is there. Again, as part of the real world example, I'll just talk about a chaos monkey. Again, it's a next level thing, but definitely if you want to try, you can try. A company like Netflix and all those things, keep using that. Again, in not all the system you can use it. Like, let's say, as I mentioned about the stock exchange can't use chaos monkey, but the system which we build, like Facebook, AWS, this Netflix, keep using the chaos monkey. They deliberately shut down certain server and see how much, if the system works fine or not, if system automatically respond or not. So this is an open source tool also available. You can go and check it out. try it out in your system, see how your system works. If your system fails or your system passes, so please use that. S3, again, as I mentioned, the 11.9 seconds. So again, 11.9 durability. There is a time in AWS S3 failed in 2015. Lots of system goes down. I think at that time GitHub was using and all this. I think 2018. I don't remember exact time. GitHub failed and all. Whoever using S3, right? Till then, S3 has basically again, as I mentioned, system will fail. But they have created a system where the impact of the system will go down. Will not that entire S3 will go down. Might be the put request will not work, get will work, or get will work, put not work. So they have changed the entire structure from that perspective. I thought to add that, but again, our system is very small, so I have not added it here. I would say the takeaways from this system is, from this session is, design for failure from day one. So when you say design, don't implement, because if you are a startup, I would say focus on the functionality, don't focus on resilience. But you should know exactly what will happen in case certain thing goes down. But if you're working in a big organization, make sure you have some idea, make sure your organization have certain kind of thing. Talk to your seniors, see that how much resilience, how much confident your senior and if you are C-level person, make sure you have idea. Someone in organization, not one, but 2 persons should have understanding that if the system goes down, how can we work on that. As I mentioned, use some kind of, some managed services, because that is important. And again, as I mentioned, resilience is a journey. It's not a destination. It's not that today you will go and say, okay, I'll implement the chaos monkey, or I'll do that, this, that. It will take time. It will take its own journey, but you should have some idea. I think that is very important. Yeah, that's all from my end. Any question, if you have, please let me know. I would be happy to answer.
I think we will refrain from questions since we are sort of exceeding the time limit.
Okay.
But yeah, thank you so much for giving such an interactive speech, and I'm glad you guys enjoyed it. Thank you, sir.
Thank you.
Okay, so now our next session explores the future of health insurance data platforms, where AI, machine learning, and blockchain come together to transform how data is managed across sectors. By integrating sources like medical records, wearables, and claim data, these platforms enable personalized coverage, faster claims, and smarter risk management, driving both efficiency and better customer outcomes. Leading this session is Dhruv Rastogi, Senior Vice President and Head of Data Science at MediAssist, an IIT Madras alumnus and award-winning AI leader. Dhruv brings 15+ years of experience delivering enterprise-scale AI solutions across finance, healthcare, and insurance. Let's give him a round of applause, everyone.
Hi everyone, my name is Dhruv and it's a pleasure to be here. I head AI and data platforms at MediAssist. MediAssist is India's largest healthcare benefits administrator. We work with thousands of corporates. We work with a lot of retail products. We work with the government as well on a lot of mass health schemes. And we also work in the international segment, right? So it's a very wide variety of gamut that we work in, right? And wide variety of use cases, running at scale as we speak. The session today is about how data platforms and how AI is sort of modernizing or is enabling the modernization of how health insurance sort of runs and is scaled, right? And when I talk about data platforms and AI, we are not just talking about digitization of data, right? We are actually talking about systems moving from a reactive phase to a more proactive and a more preventive phase, right? So these are some of the things that I'll sort of cover in today's session, right? First of all, what are the market forces that are leading this change, right? There are quite a few things happening, when we look at changing consumer expectations, right? I mean, right? In the digital first world today, where things are hyper local, where things happen in minutes, right? How are all these behaviors changing the way health insurance is delivered, right? We'll also talk about some of the future trends, right? What are the key technologies in data and AI which are sort of helping in running health insurance at scale, not just in India, but some of the key trends globally as well, right? We'll also talk through some of the design principles, right? I'm sure, in the sessions just before mine and in the morning as well, a lot was covered on the design principles in a scalable data platform. But we'll delve a little more into what are the nuances and specifics when it comes to health insurance, right? I have a slide where I show a reference architecture, right? Of course, for each insurance company, things may change depending on the kind of products they work in, the kind of markets, the way different departments are structured inside the company. But I think this will be a useful guide for us to sort of look at how things are designed, right? And lastly, we'll also talk on change management, right? While all of this is nice and cool, end of the day, I think all of us face challenge when it comes to implementation in our respective organizations, right? Considering that we all have legacy systems running, modernization has a cost, tech debt is always there, right? What are the key things that we could do so that we could also meet business outcomes but think about the future as well? So, these are some of the key market forces that are changing the way, health insurance is sort of delivered. First of all, the digital-first consumer expectations, right? In a world today where, a lot of industries are digital-first, even consumers in health insurance are expecting fast eligibility decisions. They are looking at fast claim settlements, right? They are looking at instant appointments. They are looking at zero waiting times. When they are discharged from the hospitals, they are saying, hey, I don't want to wait for 3-4 hours when I'm sort of discharged from the hospital, right? So there are multiple change in expectations that are driving this, and thankfully a lot of digital-first industries are helping in accelerating this change. Secondly, the data that we talk about in health is actually multidimensional. I mean, if you look at all the V's of big data, right? Volume, variety, veracity, velocity, and all of that is present in health data, right? We have a lot of voice data, right? Patient and doctors are talking. A lot of that is voice data. You have people who are calling up call centers, right? It could be hospitals, it could be insurance companies, it could be wellness centers, and so on, right? There's a lot of voice data there. Similarly, we've got a lot of image data as well, right? There is image data, from a lot of diagnosis instruments. There is image data from ICUs. There is image data from radiology, right? A lot of places, image data is getting generated, right? Of course, the structured data is in abundance, right? So how do we design our platforms so that all the different kinds of data could be stored, could be retrieved, and could be available at scale, right? And when we talk of the data being available, the use cases could be multiple, right? It could be for a AI engineering team or a machine learning engineering team to build predictive systems, right? To build chatbots, to build multiple other things. It could be for a business intelligence team to build dashboards, to build insights, and so on, right? So how do we build these lakehouse sort of architectures, right? So that every different consumer doesn't have to look at a different data set, but they could all look at a standard lakehouse architecture to start with. Thirdly, globally as well as, if we look at in India as well, there is also a shift towards value-based care, right? And I'm not sure how many of us are aware of what value-based care is, but typically, historically, care delivery, or let's say when you meet a doctor, right, it's generally based on fee per visit, right? Whenever you get a treatment done, whenever you visit a doctor for consultation, it's about, okay, there is a particular amount that you have to pay. That is typically known as the fee per service model. Value-based implies, hey, there is a fixed fee that will be paid out, right? And the provider or the hospital or the doctor should deliver outcomes, right? And when we move to that model, what happens is that the diagnosis tests, right, the treatment, the post-hospitalization rehabilitation or the post-hospitalization aspects are taken care of very, very well, right? Because then the provider or the hospital is actually incentivized to deliver care with a very, very high quality, right? And this is very useful for the insurers as well as for the providers and for the patients. For all the three, this model works very well. Of course, in different parts of the world, this is sort of accelerating at different pace, right? In India also, we've had recent discussions in multiple forums around that. If we look at some of the future trends, right, what are people expecting, right? So can I just get a raise of hands on how many of us have ever raised a health insurance claim? Okay. So generally what happens is depending on the kind of claim that you've raised. I mean, if it's a cashless, it's easy, but if it's a reimbursement case, it takes several days, right? There is to and fro of documents and so on, right? So one of the key expectations is, can I get instant settlement or can I get very, very fast settlement, right? That is one of the key expectations that are actually being driven by the regulator and also, in turn being expected by the members or the beneficiaries as well, right? Faster settlement times. The other expectation, which is sort of a sad reality, is also on the rampant rise of fraud, waste, and abuse in the industry, right? I'm sure, some way or the other, we've all experienced some sort of fraud, waste, right? And the expectation of the health insurers, because the problem with fraud, waste, and abuse is health insurers also face financial stress, right? Because if you're paying for claims which are not really genuine, right? Those are fake, fabricated claims. There is a financial stress on you, right? So health insurers are also expecting that, hey, I should be able to detect as many frauds as possible, right? Because more the frauds, more the problem is, right? The more time also they would take for adjudication. If they have trust, they would also be able to adjudicate and settle claims faster. And last and not the least, I mean, which is on the prevention and the wellness programs, right? I'm sure anybody who has visited a hospital or even in your organizations, companies keep organizing wellness programs, right? And the purpose of those is, how do you really prevent yourself from being sick, rather than being reactive, reaching a hospital and then getting a treatment done, right? But it's not sufficient to just keep organizing vanilla wellness programs. Today what has happened is even wellness programs have become really, really targeted. Employers or companies are also organizing wellness programs depending on the kind of diseases or issues that they are seeing in their employees, right? So this is again getting very, very data driven. So, moving on from some of the future trends that are shaping the industry, let's now move to, how these future trends and these, the data and tech, how are these being designed, right? What are the key principles basis which data engineers, data architects, and so on are designing them, right? First of all, I think everybody has heard 100 times today, cloud-based and scalable, right? I won't spend more time on that, but I think being flexible, being reliable, ensuring that our systems don't slow down is so important, right? And today, most of the data platforms are also powering a lot of AI engines, right? And the number of AI engines that are using this is also increasing day by day. So hence, it becomes extremely important to run that. Interoperability, right? I think this is something I'll actually spend a minute on because it's very, very specific and important for health insurance, right? If you look at, if you ever visit a hospital, right, you would realize that every hospital has a different standard of billing, right? They may use different names, they may have different structures, the kind of formats that they have, the kind of names that they use in the bills, they're all very different, right? If you visit a pharmacy, if you visit a lab, right, to get any test done, even there, right, what would you would see is, if you take the reports from lab 1 and if you take the report from lab 2, you would actually see a lot of difference for the same test in the way things are done, in the way things are written, the way they present everything. The challenge with all of that is interoperability becomes a problem, right? So if somebody has to actually review those documents, if they have to actually assess a claim, it becomes hard, right? Hence, globally as well as in India, there is a lot of push for standardization, right? How can all the stakeholders communicate in a very, very standard interoperable format, right? Can the data flowing from a hospital to each insurer be in a very, very standard format? If that happens, a lot of problems get solved automatically, right? Whether it's about faster adjudication, whether it's about reduction of costs, right? The amount of time it takes for adjudicating a claim. A lot of those problems, have a potential to be solved. And interoperability is sort of a very, very important area. Even the government of India has been, they have gotten a lot of standards, especially fire and stuff, so that, they could actually run this at scale. Again, I think another aspect I'll talk about is on data governance and quality, right? Because of the different types of data that is observed across the ecosystem, ensuring that data quality is of high standards is again very, very essential, right? Most of the companies, most of the leading companies today, they have implemented standard data quality frameworks, right? Wherein, every day or every hour, every month, they are looking at consistency, they are looking at validity, they are looking at completeness, they are looking at duplicates and so on, right? Having these checks, I mean, it's not very exciting, but it is something that makes your data so robust and reliable that people who use it actually have trust on the data that they are using it. There are multiple open source frameworks for this, there are multiple commercial frameworks for this, right? But this becomes extremely important in a very fragmented data ecosystem. Customer-centric design, again, is supremely important. In many industries, people have been talking about customer first, consumer first, and so on, right? It's e-commerce, retail, and so many others, right? In health, right, we've seen a lot of focus, a lot of attention now being given to patient first, right? How can we make the experience of patients better? How can we make their appointments easier? How can we make their discharge experience easier? How can we make their claim settlement experience easier? Right? A lot of focus across the ecosystem is on consumer-centric designs. Observability and FinOps, of course, I think we've all heard of it. But again, I think this has to be as part of design, right? FinOps, right, which is ensuring that we measure the cost of each and every transaction. We measure the cost of each and every API call. We measure the cost of each and every user, each and every product, right? Each and every component of the cloud platform that we are using, right? Whether it's streaming, whether it's storage, whether it's data warehousing, whether it's an AI platform that's running, it's very, very important to have FinOps built in by design and not an afterthought. Here is just a reference framework. If you look at this, right, in a typical insurance organization, you could have data coming in from multiple places, right? You would have claims data, you would have data from products, right? I mean, if you go to any online portal, you would see hundreds of products across dozens of insurance companies, right? So every insurance company has to maintain their product catalog. It's about underwriting, right? It's about reducing fraud, right? So all of the data from, which the underwriting team uses and enters, all of that has to be there. Similarly, sales and distribution is again a very, very key component in every insurance framework, right? I'm sure there are different ways of today buying insurance. It could be digital but enabled by a human, right? It could be human, I mean our age-old uncles who were selling us insurance, right? So there are different ways of selling insurance. So all of this data actually has to move into a central enterprise data platform, right? Today, most of the people talk about lake houses, so that our BI teams and our AI teams don't really have to look at two different sources of truth, right? Of course, we also have places where those are still segregated, right? The data warehouse and the data lake still sort of don't talk to each other. But lake house is the way to go. Another emerging trend is on data meshes, right? Where everything is sort of decentralized, right? The sales and distribution team run their own system. The underwriting team is sort of the data product owner of their own system. Of course, it depends on the maturity of the organization, the maturity of different teams who are using and maintaining those data sets, right? Data quality tech stack I spoke about, so this has to be a part and parcel of the data platform itself. For orchestration, modeling, data pipelines, the typical ELTs, ETLs, and so on, I think everybody in this group is aware. Access control and data privacy. This again, just like any regulated industry, data privacy is so very important for every health insurance data platform, right? Ensuring that all the protected health information, the so-called PHI information, right, is encrypted, masked, and follows the standards it is supposed to follow, right? The standards could be basis what the regulator has laid down. It could be basis the contracts you have with your stakeholders, right? But things like attribute-based access control or role-based access controls, those are things which also have to be built in as a part of design and not an afterthought. The user groups in a typical there's a cat here. In a typical health insurance setup could be, again, multiple. One could be, the claims processing team, right? There is a CRM team. There are these insurance agents who are working. There are fraud and investigation teams, right? So many a times, every claim that comes in, it's evaluated whether, it has sort of a fraud propensity or not, right? So there are AI engines working in the background that helps in figuring that out. So that is another user of this data platform, the fraud and investigation team. Similarly, the leadership might require the key business KPIs, right, and their weekly business reviews or monthly business reviews. The underwriting team, who is actually writing products, right, who's actually creating products, who's innovating, also needs all of this data, right? And I'll sort of spend a few seconds on this. I'm sure people who've seen insurance products evolve 20 years back, 10 years back, and today. There has been a lot of innovation in the way even the products are there, right? So for example, today you also have products which give you OPD or let's say non-hospitalization benefits. A few years back that wasn't the case, right? But today that is the case. There are many plans today which also give you, sort of annual health checkups and stuff like that, right? Those things were not there in the past, right? So similarly, health insurers or people who underwrite products, they are also getting more and more innovative to meet the demands of the consumers or the buyers of health insurance, right? On the right-hand side, we have the typical list of data technologies which are leveraged, right? I think for the sake of time, I'll skip that. I'll move to the next one. So I think at the data ingestion layer, there are multiple layers that happen, right? We have, every platform today has a real-time streaming integration because one, the data internally in the organization could be real-time streaming, plus we also have platforms today which are ingesting data from wearables, right? And that data many a times is real-time streaming, right? The typical batch, CDC, IoT, validation, I think I'll skip all of that. One important thing is on the golden records, right? And which is about the patient and provider 360-degree view, right? Today, many of us, if we look at it, we will have, if I were to ask somebody, where is all your health data, right? Can I just get a raise of hands on somebody who could say all my health data is in a single place? It's hard, right? Because you might have changed locations in the past, you might have visited different doctors, you might have visited clinics, labs, and so on, right? It's very hard to have all your health data in a single place. Of course, there are multiple apps today, there are many initiatives that have happened today, but having a 360-degree view about yourself, right? Where all your claims are there, all your prescriptions are there, all your lab reports are there, right? This is so very important, right? So many of the data platforms to have a centralized view for each and every consumer or beneficiary that they have, looking at their health history, right? Both longitudinal as well as sort of cross-sectional. The same thing happens for hospitals as well, right? Just imagine a hospital 360-degree view, right? Could a data platform or a health insurance platform know everything about the hospital? How many beds they have, what treatments they have, what doctors are working in that hospital, how many treatments they have done, what has been the success of those treatments, and so on, right? So that is about the golden records. One another very specific thing on health insurance data is on ontologies. And when I say ontologies, it's about standardizing or nomenclature for diagnosis and treatments, right? So ICD-11 and SNOMED-CT, these are two very classical frameworks, right? And they also keep innovating. ICD is for standardization of diagnosis, right? So for example, it could be a cataract, it could be maternity, it could be cesarean, it could be a normal delivery, it could be a knee replacement, hip replacement, and so on, right? So there are hundreds and maybe more and thousands of such diagnoses that could happen. Similarly, there are hundreds and thousands of treatments as well, right? For the same diagnosis, depending on the person, the treatments could also vary. So typically, data platforms have, for every ailment, for every claim, they have standardized names basis these benchmarks on the diagnosis and the treatments that were rendered for that particular claim, right? Only then, only when you standardize it, can you say, hey, you know what? For this claim, according to the policy terms and conditions, I should actually pay so much, right? We can't let it be vague, right? It has to be standardized basis an internationally agreed framework. Okay, I think I'll respect the timer and pause now, because most of the things that are here, I think we sort of covered them. Cloud and DevOps, interoperability standards, data governance and quality. So in a nutshell, I think to sort of summarize, there are multiple market forces that are shaping health insurance as we speak. AI and data platforms are enabling and empowering, in the successful fulfillment of what the market is expecting, right? So these are the expectations of everybody in this room and everybody outside. Whether it's about providing things real time, it's about hyper-personalization of products that you could use, whether it's about hyper-personalization of, it's about instant appointments or very definitive appointments, or it's about quick discharges from hospitals, or it's about fast and quick settlement of your claims, right? There are multiple market forces leading this change, and I think with the data and AI platforms that exist today, a lot of it is being achieved, right? There's a lot to do in this space. I think it's a very exciting space, very vibrant space. The regulator in India is also forcing a lot, right? They are also influencing a lot of acceleration, not just, let's say, in the typical corporate and the retail space, but a lot in the government, mass health space as well, right? With that, I'll take a pause. Happy to take any question. I hope the last 15 minutes were helpful in, getting some information about how health insurance data platforms are designed.
Unfortunately, due to the interest of time, we won't be able to take any questions. But thank you so much for the wonderful talk, Dhruv. It's been a pleasure listening to you.
Yeah? Okay.
Thank you so much. Good afternoon, everybody. My name is Supreet. I am from Team AIM, and we're excited to bring the last 3 sessions for the day in Hall 2, after which all of us can proceed to Hall 1 for a very special talk from one of India's and the world's greatest sporting legends. You all know who I'm talking about. If not, you will find out soon. But up next, I am excited to announce Pradeep Sharma, VP of Engineering at Cast24. So he's going to help us explore the power of real-time data pipelines, which are basically systems that help organizations ingest, process, and act on data instantly. So this session will uncover how event-driven architectures, stream processing, and scalable ingestion technologies all come together to enable use cases like fraud detection, predictive analytics, IoT monitoring, and personalized experiences. Pradeep has over 21 years of experience leading technology across domains like e-commerce, logistics, and mobility, and he brings deep insights into building data-driven systems that drive impact. Ladies and gentlemen, a warm round of applause for Pradeep, everybody.
Hey guys, am I audible? Okay. All right, so yeah, the introduction was super techie. I would not be having that techie kind of discussion right now, because also they talked about my experience to be 21 years. This year, yeah, it is 23. So we are kind of just catching up. And those people who would be having similar kind of experience, you'll see that over a long career, almost all the tech frameworks upgrade and change every year. And every 6 months you have new frameworks coming up, new way of working coming up. We have seen this with data also. Whenever you start data engineering team or data platform team or data science team, there's always a discussion related to as to what you understand, what are your skills, what is the value add that you have done in the previous organization, what kind of use cases, industries that you have worked in. I've been part of, I've just heard a lot of my fellow speakers yesterday and today. What I see is that everybody has covered to a large extent as to how to do things. Almost 50%, more than 50% sessions are related to how do you do things. And some of the sessions also talked about as to what you will be able to achieve. What organizations are trying to do. A lot of organizations that you have heard from, they are trying to catch up. They do not want to move as fast because of just like the last discussion. Medical or fintech, these kind of organizations need to move slower. They cannot move as fast. You cannot make a certain decision today and tomorrow you change your mind and you say that, okay, no, this is not how we are going to do the things. We are going to do the things differently. And that kind of stability or lack of stability can hurt those type of businesses. So I'm representing Cast24 today. There are no slides which are Cast24 architecture deep dives. And also though these guys told me that I need to keep the font size to 24 or plus. I tried to bring it down to 15, 16 only on the hope that probably a screen will be bigger. So I would start my session and I would also try to catch up to the time because I want to meet MC Anil Kumble. And so in this particular session, essentially we'll just try to review as to what has happened with software engineering, data engineering over the last 3 decades. You would have people who try to understand that there is a problem, can be digitized, and then it can be automated. And then somebody somewhere who is expert at that particular problem will be able to solve the problem for everybody. as well as that person is able to solve for one person. For example, for edutech, if there is a good teacher, the teacher is able to do a very good session with 30, 40, 50 students. That teacher would want to leverage technology to reach out to thousands of people, millions of people asynchronously over a period of time. So the internet speed, data, multiple type of data points. For example, previously you would see maybe some particular form being filled, and very reluctantly some people will fill those forms. Some people will very excitingly fill those forms 30 years back and get their information online, because maybe there is a Yahoo categorization which is there, which is going to add value to some other people. So today I would not focus on how, because there are a lot of experts, and maybe in the last 1 year when I was at I was trying to solve the problems related to NBFC at Cars24. Cars24 has a business unit which is registered NBFC. It is named Cars24 Financial Services. It gives used car buyers loan to buy the cars. Then it also enables its dealers across the network to leverage and get some kind of operating capital for every car that they buy through Cars24, and then they will be selling it afterwards. So we have tried to reshape that entire NBFC to a fintech which can give more financial products like personal loan, credit card, insurance. It can give loan against car, refinance a particular loan, etc. So I was trying to solve this particular problem over the last 1 year. Not much of data engineering learnings that I've had. That's why I don't want to keep it very technical. But again, I would say that if you talk to a data engineer, there was a software engineer. That software engineer in 5 years became what you would say a data aggregator, would do some kind of crawling, get from all the sources in the internet with Google coming in, that I would want to build my own internal Google search engine. Then indexes came in, search came in, you would pipe the data, you would have somebody act on that particular data. Thereafter, you would have not only certain mediums, your partners that are giving you the customers or the data, but there are multiple new aggregators coming in, multiple sources of the data coming in. Everybody using the latest technology, but after the 2 years, the technology changes, and now everybody is trying to use the latest technology again. So different file systems. You started from some XML to JSON to Avro to Parquet. Various different type of innovations coming. And any company that is running, or if you would be starting it today, certainly it is the right place for you to understand what kind of data structures are there, data stores are there, data streaming platforms are there, frameworks are there, data warehouses are there. How do you get all of this particular thing without having the data leave your premises or work with different clouds with the security? All of that is possible. So these guys formulated into more of a data engineer. Then these data engineers started building models, putting their brain or part of their brain into some particular programs that we have been doing from decades, right? Business rule engines coming in. And then these guys became data scientists. Then they became machine learning engineer. You would have some data you cannot trust. You know that that particular data is probably 5 years old, 2 years old, or a month old from another organization. You would want to have your models work better because everybody is starting a startup without data. But you would want to have the startup as relevant as some company which is collecting data from 5 years. These ML engineers slowly started becoming, as one of the sessions earlier talked about NLP, then they became AI engineers. Now you are like, it's the same stream, if you ask me. Essentially what we are trying to do is we are trying to automate the stuff and have, maybe if your team has a champion who is the brain behind your startup or your product or a particular P&L or a particular service, what we are trying to do is we are trying to replicate the efficiency and effectiveness of that person. You're saying that, okay, one of my, for example, fintech again, collections agent is a super champion. This guy just convinces the person, reaches at the right time, does the right kind of discussion talk, and has 120% of collections. What do you want to do then? There are startups in Europe who would be saying that, okay, I would get my agent intelligence put into this agentic AI, and then I would want all of my agents, which are like 2 months experience, learn from this guy who's a champion and do it all over. So you have like 100 champions now. So I would want to dive deeper into why do we have data engineering and why do we require these type of real-time processing also. With this, I mean, if we move to this slide, it took me a lot of time to search for a cockpit view of a F1 car. And when it was running, it was showing all these different telemetries. So if you think about it, essentially all the internet products, they came into life with synchronicity. They were sync products. You'd ask a question, you'll get some answer. Or maybe somebody just dumped the information, it's a reading kind of information. Otherwise, there is always somebody at the other end. Now what you want with all these different type of data sources coming in, the data size increasing, the internet speed increasing, now the data started becoming the problem rather than a solution. The size of data was so much that you would not be able to do this real-time type of stuff, which is what you want to do, because if you're running if you're driving and if you're running car or even on a highway, you would want to have that kind of awareness, and you cannot take the decision that I'll learn from today's failure, I'll fail in every race and learn from that particular failure, and maybe next race my engine will be better, my tires will be better, my aerodynamics will be better. We cannot just wait for that. So we went from a real-time synchronous kind of systems to more of like better systems with more data visibility and better intelligence. We are again coming back and saying that that does not solve the problem. Analytics does not solve the problem. Can I have a response or a reaction that somebody actually is noticing me, or this particular system or this company knows about me? That I had discussion with one of their folks a week back or 2 weeks back. Or I always try to search for this particular company's, say, FAQ page whenever I visit one of the locations or a dealership, for example. So if you do not have that particular type of response and that kind of information coming back to or appearing to your customer, the customer would just feel that, okay, this is maybe very static kind of website or app. I always go and I always follow this particular flow. There is no customization, no personalization. These people do not know me, they don't understand me. So they'll not be able to connect with you. So then you are very much limited in type of offerings that you'll be able to do. This is the journey we just talked about. Everybody started building batches because, hey, I cannot keep that many number of, say, threads in my server. I cannot have that many lines open. That particular connection needs to be broken. The pipe cannot be kept for eternity. So everybody started solving this particular problem with batches. Then batches became micro batches. Then you will talk about some of the providers outside, some exceptionally good at small batches, micro batches. Others talking about streaming. And then you need to understand as to when we are solving all these problems, why are we trying to solve those problems? So the why is very important, because you need to understand not all business decisions need to be immediately in this particular moment. You need to give some time to the customer sometimes. You will also take some time to come out with a more deep dive kind of thinking, wherein you are collecting the data information from all the people, the reactions that people gave. For example, the event happened on 5th or 6th of May. the reactions started pouring, but all of us might have read those reactions a day later. Because that time you are able to collate that it was not an AI generated image, it was not a bot posted comment, it was validated, and there are a lot of deeper insights that certainly come after certain time. So it is not possible to do everything in the real time. So you need to very judiciously, cautiously choose those particular use cases wherein you would want to go real time. Now, how do we make things real time? So this is just one particular lens of looking at real time pipelines, as we say. Some of the major stages of a real time pipeline. Essentially, we see that there are some problems we need to solve, because why do you want to have event emitters? You want to have event emitters because everybody is told that if you give me this type of event, I understand it. If you give me maybe some particular raw event, it is definitely some transaction, some event has happened. But if I cannot make sense of it, I'll not be able to do anything later on. So there is some kind of contract which is negotiated. Events need to be emitted at what particular frequency, which system, what type of event, what is the size of the event. And thereafter, you would want to say that, okay, I have defined this, now I need to maybe project as to today I will be having these many customers, these many events, these many leads, these many marketing kind of interactions or engagements, and then you would want to have that ingested in your system. There needs to be an engine to process all this particular stream, right? We'll talk about, I'll probably have a reference of a couple of such engines, but what you're trying to do is that you are saying that event stream is there available for consumption and processing. You process it, and what do you do? I mean, it can be one single step kind of processing, or if you're saying that, hey, I understand that this is a profile update, for example. Does the profile update needs to talk to some other event? It needs to be aware of some other event happening. It needs to be aware of the same customer's events happening 5 days back. Can I pull in some kind of insights from there, and maybe for a fintech you would want to do a fraud check with that particular profile update. This person changed the name, or changed the address, or changed the profile picture. Is there a fraud check required now? Maybe yes. Then what you would be saying is that this processing is not only processing of that particular image which is uploaded, but you need to be maybe running through the entire data warehouse in some way, or maybe you would want to understand what's the big difference between the previous and this particular image. Is the person changed, or it's only a aspect which has changed? So real-time enrichment is the next important thing. Essentially, the context you are adding, or you are trying to join some of the other context to it, that is only when the enrichment will happen. And then you would want to keep dumping all of this particular data. As in one of the previous sessions, we talked about the raw data wins over everything else, because essentially you can recreate the entire thing. For example, for resilience also, you can have your CDC, and that CDC is essentially event stream. You can recreate your update deletions of the database also. So you need to have very low latency database, which is for persistent. Then if you're talking about real-time, insights need to be popped out of the system, then reads also need to be real-time. Analytics layer is the more from the perspective of that, okay, you are doing only the reading at this point of time, and maybe you would be improving your processing engines or your enrichment frameworks or your schema, modeling, etc. But it is very important for us to understand that, I mean, real time does not mean that, okay, dump all the data that you want. And whatever size, the size just increases. My S3 bucket size keeps increasing every month and every week. And it creates more problems than it solves. So data streams flowing in, there needs to be some kind of cataloging, there needs to be some kind of lineage identification, and that is where you will also try to map that, okay, somebody put in that particular data, then that producer of that data would also want to define as to who should be having access to that data. So there are a lot of different taggings and mappings that need to happen for that data to make sense later on. It can be a customer 360, it can be partner 360, it can be related to maybe a particular campaign, entire picture of that particular campaign. For example, for Cast 24, any customer walking in starts a chain of events. What would the customer like? Where did the customer move? Which type of car? Which particular model? How old would that particular customer, the car the customer would be looking for? And then you try to marry that particular data to your previous experiences, your cohort, your campaign, and everything, saying that, okay, my campaign is successful, my layout of the dealership is fine, the cars that I have posted there are also okay or not, the customer is satisfied, would he want to maybe reschedule it? Would I be better giving that particular customer another car that is just in refurbishment and will be available 2 days later? There are a lot of things that you can do, but again, you would have raw data. Raw data will not be as important. The only importance is the context that you can put to it. I mean, I believe that everybody understands consistency, partitioning, and availability. So I'll not be talking about that. For all the tools that are there, some of them win in terms of the batch sizes or real time. Some of them win in terms of where they can ingest the data faster from. And some of them are able to do that particular data modeling, remodeling, or mapping much faster, right? And all of these tools have over time just improved and improved. But you should be approaching it from the perspective that, hey, maybe I need to look more from the perspective of my business need. What is it that we are adding value to, and what is the system that will be able to enable all of this? Because at the end of the year, when the annual plan is again made, you would be asked the question as to why did we build this particular technology? Whether we were able to measure the success of this also. This is Metascore available on the internet. You guys can see that, yeah, Flink is kind of just winning. Kafka started from more of event versus and streaming, so they were thinking only in terms of that. And Spark also worked very well when everybody wanted to reduce the batch sizes, but Flink is more real time. This is just maybe one type of mind map I tried to create. It was very hard. ChatGPT was not able to understand what I was trying to say. Maybe you people will be able to understand. So we have all these events and all these different type of identity or transaction events coming in, but there are always some processes or enrichers or doing some kind of cataloging and trying to relate to some other data. And then you add your value. You maybe streamline, like one of the gentlemen talked about that, yeah, they were from the arrays, they were putting in a singular event from Redbus. So essentially what you're doing is that is more of cleanup, and thereafter if you add some other events to it, that is the enrichment. After you have done the enrichment, yes, you would want to have real-time dashboards rather than dashboards. ClickHouse talked about fast boards yesterday, that they call it. Wherein what we are saying is that all these dashboards are more of a pull kind of model. You have the data somewhere, you have built a particular query, there are some KPIs you are looking at, and you are showing those KPIs. Still, the person who is making the decision, taking into account all of this, looking at all of this, is the decision maker. You still have not been able to have a real-time decision maker, because how many people will be looking at it? One of the medical company startup, I visited their office. They had a huge screen, similar size, in a room which is war room, and they're looking at that dashboard as to what is happening today, how's the business today. We are trying to build similar kind of dashboard for Cast24 Financial Services also, to see as to how it is going today. But still the decision makers are people. You would want to move away from that. But again, you are not saying that we will not be needing warehouses. I just walk you through one particular instance wherein warehouses are going to have that contextual information. How many of you take pride into your tradition or your culture? It is kind of viral these days, but yeah, that's very long back historical kind of learning. Do you not want to have historical learning? If your answer is yes, you'll not require data warehouses. Otherwise, data warehouses are there to stay. They were there. It is going to be maybe just improve. On each use case, you'll try to take that particular decision whether I want it to be available in 9 minutes, I want it to be available in 1 day. When is that information or product is to be delivered? So we'll be not talking about dashboards, but we need to have systems wherein these insights are created and they are persisted or they trigger some kind of actions. We are able to map some actions to them. That if there is some particular insight which has come in, this number has gone up or gone down, then what is the action that I can take? So your systems are not only trying to create all this information and generate all that data, but you are also trying to say that my systems are able to take in the insights and implement some actions on those data also. This is where you will have some kind of decision engines, and you would want to have some kind of microservices because they can take care of that type of stuff, rather than somebody just importing that, okay, this is the campaign that we want to run today. Rather than that, would you be able to run a campaign or start a campaign tomorrow or maybe in the next 1 hour? Everything boils down to this. You start a company, start a product. For survival, you take a long time. You're doing something very different which nobody is able to replicate, 0 to 1, if you guys have read Peter Thiel. And thereafter, can you change? As I talked about, the frameworks upgrade every 6 months. New frameworks come in. And new technologies come in. Sometimes those technologies are very good, but they don't survive because the community is not there. Maybe a lesser 95% efficiency technology survives, which has a better community. So the tools are not that important. What is important is you need to understand as to what problem we are trying to solve, what are the ways, the first principles to solve those problems. So if you have agility and flexibility in your system, then you will be able to grow and grow. You'll be able to create 0 to 1, you'll be able to grow 1 to 10. And there are various different use cases wherein maybe, you will be able to have that type of company which is fintech, which is having least NPS. Or you would be so personalized that people feel connected to you, that this particular app just talks to me. Innovations happen actually there. We cannot take time's up questions, but again, I would just posting one question to you guys as to, we should be asking ourselves, our team and people we work with, as to, everything fast and real time is good to have, great. But what is that one thing, that rank order 1 or P0, wherein we distinguish if we respond in real time to a particular customer event or interaction and make a difference? Because that particular difference is going to differentiate from other companies, other teams, and other tools or stacks. Thank you.
Thank you so much for the refreshing session, Pradeep. So our next session dives into the strategic data engineering practices, where we unpack how scalable architecture, data quality, and automation come together. And leading this session will be Shankar Gowda DM, who is the Deputy Vice President of Data Engineering at HDFC Bank. He's a seasoned banking professional with a deep technical expertise, and he brings a future-focused lens to digital transformation. So ladies and gentlemen, give a warm welcome to Shankar Gowda from HDFC.
Good afternoon, everyone. Hope we are still focused and have the energy maintained. I know there is an exciting session going to be happen there. Good, yeah. So, data engineers, we are like, most of the time always called as unsung heroes. No, I don't think we are no more accepting that we are unsung heroes. Actually, we are singing loud and loud now, and things have been recognized. Over the period of time, we have grown, and at a very high level, it has been recognized, and everybody understand how important our contributions are. For the success of AI journey and the complete analytical steps are happening across the organization. Yeah. So let's go through the today's focus. Now I have an AI agent, taking us through what will be the today's focus that we'll be talking about. Yeah.
Hello and welcome. I'm excited to share today's agenda. Best practices in data engineering, a key foundation for building robust, scalable, and reliable data systems. In this brief session, we'll walk through essential principles that help data teams deliver consistent, high-quality, and business-ready data. Let's get started. First, design your systems with modularity and scalability in mind. Structuring pipelines into smaller, reusable parts makes them easier to manage and adapt as your data grows. Second, focus on automation and reliability. Reducing manual steps improves consistency and minimizes human errors across the data lifecycle. Third, ensure strong data quality and observability. Validating data at every stage builds trust and prevents issues from affecting critical decisions. Fourth, implement version control and structured processes for managing changes. This fosters team collaboration and helps maintain stability as systems evolve. Fifth, manage your metadata and data lineage effectively. Understanding where your data comes from, how it changes, and where it goes enables better governance and transparency. Sixth, prioritize security and access control. Protecting sensitive data and managing permissions carefully are essential for compliance and user trust. Lastly, promote collaboration between technical teams and business stakeholders. Clear communication ensures that your data efforts align with real business needs. As data continues to grow in complexity and value, these best practices will help your organization stay efficient, trusted, and future-ready.
Well, yeah, thanks for it. And how data creates the magic, right? This is the introduction was the one of the example. So the data that we fed, this is the AI agent, and definitely it works based on the data that we are feeding it, So let's talk about the modularity and scalability. I'm not talking much about the technical things because it differs from the organization to organization. Now a lot of things have evolved recently. There are multiple technologies, tools are there. So in a nutshell, very high level, the modularity, scalability, what it means and why it matters, kind of thing, right? So about this, right? We like while developing the pipelines and all, we all know we have to break down into the silos sometimes, and into the smaller and independent tasks, right, to make the things much more seamless. Yeah, but data engineering, while doing the regular ETL stuff, it is not just about like nowadays data engineering is not just limited for the ETL and building the data, integrating the data and all. So it is very essential nowadays for the data engineers to also have in-depth knowledge about the platform. We should know what are our platform limitations, because all the companies, there are multiple startups nowadays. There are well-established organizations, right? So not everyone, everybody talks about the AI. Okay, everybody talks about the AI. Everyone wants to modernize their architecture, but it comes with the cost, right? So there are certain limitations. So within the boundaries, the given boundaries, tool stacks, and the platform, the best out of the data can be derived. It is made possible by all of us, the data engineers, right? So we have to understand the platform limitations, what are our boundaries, and then within that we have to automate all our ETL pipelines, breaking down into the components, and then do the regular things, the validation, loading, the regular things that we do. Okay. And breaking down into the smaller things, right? Of course, it is easy for us to manage if we have things, broken down into the smaller things, and it is always, we should be ready for accommodating the changes. So, we all data engineers, it is not just about the automation things and it will run, okay? Because our pipelines, after automation, it should also keep serving the incremental need of the data. It is not like, we have developed, deployed to the production, and our job is done, okay? So even post-production also, so it should keep on serving the incremental need of the data. Okay, so we have to also keep the platform, related aspects in mind that we have automated, and because we always expect the changes in the data. While development, we might have developed certain things on a specific set of the data, and in the quality environment or the testing environment, we do these things a certain interval period of data taking into the consideration, and we complete the automation, right? But in the production, as the data keeps on coming, keeps on growing, right, we should always keep all those things into account while developing all these things. And also, as much as possible, we have to create the reusability, of course, like we are all doing this one. But coming to the data products, like how are we going to reuse the data, the incremental data coming into the picture, we have to take all these aspects into consideration and create lots of reusability in terms of the data and considering the platform related aspects in mind. Yeah. Next one is kind of automation and the reliability. Yeah. So basically, the automation requires like we do it. I don't want to sit every day and do it manually, bringing data from here and loading to the target. It is not just limited to that, right? So in addition to that, we should have a strong the monitoring capabilities, and we should also take our stakeholders into the confidence always. Yeah, because data engineering and the ETL, it is not just limited to the data engineering team. If we develop the pipelines, provide the data, job is not done. Okay, we should also have, because many of the time, like I could see, the data engineers will not have the visibility, who is using this data, where this gets used. It is very important, for all the data engineers or the teams that they are building. They should also have, some sort of a business insights, like where it gets used. And while accommodating the changes, you will automate once, but we have to keep on accommodating the changes. We will get lots of enhancement and everything, right? So, if we need to accommodate those things, right, we should also, consider, they should be aware of the usage, the consumers of the, the data and the nature of the systems which consumes the data, right? So they should be, aware that, okay, how the business continuity, should happen, and also we should accommodate all these, the changes that we will be accepting. Yeah, and then, for that one, we should build, the complete end-to-end, the data ingestion framework, and there will be, certain, the reusable components must be developed to take care of the accommodation, because not every time we have to automate. There will be lots of ad hoc activities to take care of the certain needs. Yeah. And then why it matters is, of course, reduces the manual intervention, and then we need to achieve the consistency in the data delivery. Yeah. And the trust, that on the data consumers, right? So the trust, and we have to take them into the confidentiality, right? So it is very important, understanding the complete business requirements, and then align to the complete business requirement and build our pipelines, making use of the infrastructure that is available, because the expectations are always high, and the what has been given to us not necessarily always it will be everything, like the completely fulfilling our needs, right? Yeah. And about the data quality and observability. Yeah. Data quality, I don't think like we need to yeah. Of course, it is a very important thing. It is a essential, very essential part indeed. Yeah, it has to be there. Yeah. So now most of the time, what we do, of course, like we do ETL development and we do the QC, till where we do the or consider the data quality aspects, right? So most of the time during the development phase, some sort of basic checks that we do, and in the testing phase maybe we do more oftenly we do lots of kind of testing and all. But what happens if it goes to the production? Are we serious about the data quality when it goes to production, or it is just limited to the non-production environment? That is a very important thing, right? So most of the time when the data comes to the production, right, the cycle that we follow, the development, testing, and then the production, okay? And I'm sure you all might have faced this situation that there will be data issues in the production, and which has to be fixed on the immediate basis depending on the severity of the issue. And data engineers will be tied their hands with the processes, right? So then you may say that it has to be fixed, you have a business pressure, but you need to follow the process. I need to go via build if you are following Agile. Some other project methodologies, the processes, they are here for the good cause, but of course sometimes it will tie our hands, right? So you have to do it again in the test dev environment, do the testing and all. So this has to be robust in nature, yeah. So that means we have to take the data quality aspect also very seriously. And so why can't we have the parallel, or why can't we integrate the data quality aspects within our ETL pipelines? Okay, and why can't we have the fail-safe kind of option? If I would like to give an example, right? CDC, you all know, like CDC, the way CDC is implemented. Again, it is there are multiple ways. Some guys might use golden gate, click replicate. Some multiple technologies are there nowadays. Okay. So what I suggest is you may or may not be following. Like as per my this one knowledge, what I suggest, because this helped us a lot in a couple of the teams and companies that I worked. So for the CDC, it is not just about real-time ingestion of the data, capturing the changes. And our third process while building this kind of real-time ingestion, it should not be just limited for the ingestion and just for the consumer perspective. You also need to understand the upstream, okay, how the upstreams are designed, okay, because this field, I think it evolved recently and the expectations are high, and we think our limitation is only within the data platforms. So we should extend, start thinking about our upstream systems. Okay, I work in the banking, there will be retail, there will be other healthcare and other industries where everybody will have the customer facing or the core applications or the core things, right? So, and another thing is that we are not the creators of the data. Data engineers, our main job is to enabling the data, right? So if we think about only the ETL pipelines that we are building, we should also see for doing the CDC whether the upstream system is capable of giving the real-time data. Okay, is it capable of, is it like did it build did they build this system for providing data as a service in real time? Sometimes if we suddenly develop all the real-time integration and plug into the core systems, and it will stop working there. Okay, so the first priority is the business continuity. That is designed to serve the customers, not to give as a data as a service. So we should have all this understanding, and then have it started at the upstream level, not just start building the pipeline. The one thing, yeah. And another thing is data quality checks. So how are we relearning from the the quality issues that we are getting? So that is also very important, right? So see, some issues comes, what kind of issues will come: junk character space, DDL changes, the typical things, right? So if we address all these things, job is done? Of course, no. These things may come again, yeah. And are we, in all the companies, are we the only one who are consuming the data from a particular system? There will be multiple downstream who are consuming the data. So how all these downstreams consuming the data from a particular system are collaborating each other and ensuring the issues faced by one team are efficiently communicated to the other teams, and together communicated to the core teams and addressed at the core team and prevented for them coming again and again, right? This sort of thing has to be done. It is already process-driven kind of thing. These kind of things, these two things that, the compatibility and readiness of the upstream system for giving data as a service, are they capable or not? Then, decision making, of course, important, but we have to, make that it is waiting for some time, then go and prepare those upstream systems so that your future things are like you will not going to, rework, or otherwise you will end up reworking a lot. Data engineering team, I think this is maybe other teams, but this is the one of the team where lots of rework happens, right? Yeah. So we have to ensure that we have to tell that yes, this will be delivered. Prerequisite: prepare the upstream systems which can efficiently provide the data. It is not about just taking the data kind of thing. Yeah, and data quality aspects to be communicated. Okay, it is not just if there are issues, if I fix job is not done, take those learnings, consolidate all those learnings, collaborate, among other downstream, because all will be working in the same organizations or maybe different projects, clients, something like that, and try to collaborate, consolidate, and go to the upstream systems. Try to address as much as possible in the upstream systems. Yeah. And version control, structured process, So versioning, it is pretty simple that, versioning means code versions, simple definition, right? So how different that we can do, like what are the things that we are not doing currently, right? So what kind of persons will see? Every time, I will not talk about the regular things that we do. We get the requirements, build the pipelines, load the data, right? You all know, it's a day-to-day job for us that, suddenly we'll get a requirement that, for example, like in the banking and from marketing campaigns, or there is a festival, we have to immediately trigger the campaign. For some festival, we have to immediately trigger the campaign, bring the data, Then we have automated all the code. It has to be run in the production environment and the banking. How will you run it? Because that was not part of our automation, right? So we have to build the reusable, and we have to how the, and this cannot be misused also, right? Anytime you cannot run anything and load anything and trigger the campaigns and all, the version controlling plays a crucial role. And then the regulatory and the governance also, it helps. The versioning helps for the governance model also, it is very essential that to know what code is running and this is responsible for what purpose, right? So it is not just about versioning the code. It also helps maintaining the compliance body, okay? And it also plays a crucial role in the regulatory. The regulatory team may or may not be knowing that version controlling is helping us, but this plays a crucial role, but whatever technology, of course, depending on the feasibility infrastructure we use, but this concept is very important, and we have to design things in such a way that, all the ad hoc things and, all these things we should be able to address within the proper the compliance and the governance body, yeah, something like that we should build it, yeah. And it also helps, it is just about the addressing the ad hoc things to meet the immediate business needs, and of course, many times we will not be knowing because of which what has failed kind of thing, right? This is a real thing. If you have the version control, it helps us that, okay, to backtrace, go across the lineage, which connected all the dots, from source of truth to end, it helps, split the things and all, and properly identify where is the cause and fix it and all, yeah. And if you want to roll back and all, in application world it happens pretty easily. You can roll back things and all. In data world, it is a painful job, right? You have loaded so much and then you roll it back, and it's a lot of painful job that we all go through it, yeah. And it brings a lot of discipline in the because the architecture, most of the time we make it more complex, right? You see, we will start the raw data acquisition, then we will think about the building dimensions, facts and all marts. Then we is it limited to that one? No, we will starting data modeling. We think that, okay, we will acquire the data, then build the dimensions, then build the marts, then we will end up building marts on top of the marts. Okay, then it is just we'll start with just basic satellites things and all. Then after that the universe, then super everything. It keeps on going, marts on top of marts, marts on top of marts. Then over a period of, if you look back and see, we'll see what it is, kind of thing, right? So for that, it is I will talk about the metadata kind of things, right? It is very important to have the metadata, right? So metadata, basically we think that it is the data about the data, but it is not just limited to the data about the data. So data about the data, that other data is not just related to our data, yeah? There are many more things, okay? So data engineering team must be aware of all the information, not limited to the what are all the sources, what are all the indexes, what are all the table that we are bringing. No, not just limited to this one. We should also know what are all the the technologies that we are using, what are all the technological the pros and cons that we have, what is the limitation, and we should also be aware that the other aspects like the cost, efficiency, because we talk about like ad hoc activities I told, right? So if you don't have the information about the platforms, if you don't have the information about the requirements, each and every aspect you take, it can be the insights that you are deriving out of it, and it can be about the projects, and it is not about just bringing the data, pushing it for one project. You should also identify, how many places or how many consumers, how many projects are using this data, and we cannot, create always, in silos and acquire the data and keep it at one place for each project, in a separate places, right? Like we have to ensure that the reusability is happening, yeah, and all the changes and the things those are happening right across all the project level requirement, everything that requires for this complete integration and all. We should have all the information, not just limiting to the data, indexes, and the tables, column schema, etc., etc., all these things, right? It is not just limited to that. It is like more than that, I could say. Then only it will help for the data discovery and things, right? Many of the times, as I told, I give an example that we'll start building dimension facts, then marks, one after other, it will keep on increasing. So essential metadata, it builds the confidence, it builds the confidence for the consumers, and they can look back, because many of the business opportunities starts looking at the data that is available with us, yeah? I think that is there. I will just move faster. And the security and the access control, yeah? So there are lots of aspects, right? Nowadays, like we have to ensure, all the, role-based access, and also like sometimes we, face the challenges. One of the challenge that I faced was like, it's multiple verticals, they have the data and they don't want to see each other's data, but the data is residing in a single table. It's a huge, like I cannot create it in silos, right? There are like lots of conflicts that, I want to see, two teams wants to see the same data, other three teams don't want to see each other's data. And then in that case, we'll go for the row level security. Then we have our back ensuring the, right users, authorized users accessing the right data. So all these things matters a lot, and it avoids the data mismanagement, right? So data mismanagement, happens inside organization, even outside organization. For as like a bank, so we are like more concerned that data, can never be mismanaged, misutilized internally or the externally. We are very cautious about it, and we build the right set of the processes for it. And the promoting collaboration. So collaboration, not just limited to like we have the Scrum team, sprint, something like we use like just for a project team. It is not just that, the collaboration, if it is happening between, among data engineers, data architects, solution architect, so I feel the collaboration should happen with even the stakeholders, the businesses, because many of the time I hear the feedback from many of my team members that, we are bringing this data, for what we are bringing, who is using this data. That transparency is a very important, essential for the data engineers, and that collaboration should happen along with the business, and everything that we are doing, like we are automating the QC. So you will definitely have the alerts configured and all. So I encourage that include your stakeholders into the alerts. Hey, today we have executed this, we have processed this data, for consumption, and today we have processed, but there are some failures. So this brings the transparency, and it increases the confidentiality of the stakeholders who are consuming the data. So make them part of the alerts and all, Yeah, so that's the thing, So we should always in sync with the data engineers, and we have to establish this relationship between the data engineers as well as our stakeholders. It is very important, and it should be insight driven. Okay, it is not just about we build and all. For the leadership or for the stakeholders who are consuming the data, we should also create the awareness that through the insights, like what we have created, what it is in terms of the stats or the numbers, and how it helped the business. So we should be able to connect and relate that whatever effort has been done, how it is helping, so that so that it helps and it creates the realization for the stakeholders, and then it improves the confidentiality for us as well as to the stakeholders. Yeah, so that's all I have, yeah, for the day. And this is vigilante for the the campaign, the safe data sound sleep kind of thing. Of course, we are data engineers. If we have our data is safe, then we will have sound sleep. And if something goes, means I'm sure like we like many of the time we end up working late nights, and wherever we are we have to yeah. So hope we all build the solutions which is safe and sound sleep and like enjoy our time and all. Yeah, that's good. And now we are proud. Now we should feel proud that each and everything starts with the data, and we are the creator of it. So we should all feel proud, as a data engineer. Yeah, that's all for me. Thank you.
Hello. Thank you so much, sir, for your great words and a motivating session. Now we are nearing the end of the evening. We have reached our last session on architecting data quality, trust, reliability, and modern data stacks. So this session explores how organizations can build robust data quality frameworks from ingestion to consumption. You'll learn how to implement automated testing, monitoring, governance to ensure data reliability at scale, and discover emerging tools that enable continuous quality assessment even as data volumes and complexity grows. Leading this critical conversation, we have Mr. Ram Yamal, Head of Data Architecture at Vassal Group, Dubai. With 27 years of experience driving data enterprise strategy and AI transformation, Ram is a thought leader in analytics, governance, and intelligent automation. Please join me in welcoming Mr. Ram.
Am I audible? Good afternoon, good evening. I know a lot of people are probably packed up in Hall 1 to get a glimpse of the finest cricketer that India has produced over the last 20 years. So I'll keep it short. I have around 12 slides or so that I'll walk through. I know a lot of speakers talked about data quality, so you might hear something that's very repetitive in nature, but I would like to get my experience over the last 20 plus years that I've worked in this field. I've worked in various domains. The current domain that I'm working on definitely gives a lot more challenges because it's the real estate domain that I'm working on. And any organization that's actually going through a transformation will look at data quality being one of the critical components and one of the most challenging components to work on, right? So the topic is not just about understanding data quality, it's also more about how do you build a trust from a capability perspective. You have a data platform has 10 different capabilities, right? And data quality is one such capability. So how do you ensure that your business users have the trust in that data quality component itself? You probably would have seen all of this. Bad data costs organizations a lot of money. I have a few examples of that when such scenario happened, right? Fortune 500 company loses 20 million because they launched a product with duplicate records, right? That's one classic case that you see. Healthcare, there's incorrect patient records, and there was a lawsuit which cost the company 12 million, right? There's financial impact. A lot of financial organizations go through this. There is regulatory requirements that you need to cater to, and if you don't adhere to all of that, then there is fines, right? So these are actually realistic numbers, but I didn't want to show which organizations they are from. So what is the data paradox? I mean, a lot of organizations talk about I have
lot of data will generate a lot of insights, but at the end of the day, the executives keep saying we are not able to make the right decisions, right? So what is this data paradox all about? So from an analysis perspective, there is trust crisis. All of the data analysts or business analysts or people that do exploratory data in your organization say that 32% of the data that they look at is non-trustworthy. What that means is there is problem with your data that you either process or you capture, right? The second aspect is growing complexity. When large organizations been there for 20 odd years, they have legacy systems. On top of it, they do transformation projects. They bring in new systems in place, right? So adding to all of this complexity is the number of data sources that you're going to get the data from. And then there is exponential growth of the data itself, the volume of the data that you collect from various sources, not internal applications, but also external to your organization. What I have not covered is one of the important aspects also is data quality actually doesn't get the visibility it needs to. If a company's online retail portal goes down, right, there is red alerts across the organization, but that's not the case with data quality. If data quality issues are there, yeah, we can fix it, we'll try to fix it, right? That's the answer that you get. But the underneath problem is this, right? You end up making wrong decisions, right? That's not something that the leadership team thinks about, right? So ensure that data quality is given the visibility that it needs to within the organization. The other aspect also is data quality is always thought about as a technical problem, right? When there is a data quality issue, it's given to the data engineers to fix it. Where is the business involved in all of this? We talk a lot about data management. We talk a lot about how business needs to be part of the data management aspects, right? So you need to have that culture where your business folks are also involved in your data quality decision making, right? So ensure that you do that. Now, what does the modern data quality crisis look like, right? So you probably are aware of these 6 pretty common dimensions that you see in data quality, right? Which is about, is your data accurate, right? If your data is accurate, you probably see the right numbers in terms of your data insights, right? Is your data complete? Am I actually capturing the data from across all of the sources to make the right decision, right? So you need to ensure that your analysis of your data landscape or the assessment that you do is pretty solid enough that you can make the right decision about the data. Now, is your data relevant, which is very important, right? Because at times, your business users will actually keep looking at the numbers every day, but they don't seem to understand that the numbers are stale, right? Because your data engineering processes have been failing over the last week or so, right? So you need to make sure that you have the relevant processes or monitoring in place where your data is fresh enough, right? So if you have your ETLs run once a day or maybe twice a day or maybe 4 times a day, you need to ensure that you have the right mechanism in place to make sure that you monitor it. Uniqueness, right? This pretty much applies to probably in a master data kind of world, right? Where you have different master data domains, you have customers, you have products, you have suppliers, right? How do you ensure that you're not creating the customer across different systems in your data landscape? So ensure that you have uniqueness within your data, right? You want to understand how big is my customer base. Am I looking at 5 million customers? Am I looking at 10 million customers? If you're looking at 10 million customers, are you ensuring that you're not duplicating the same customer across different platforms that you have? And then validity of the data itself, right? Classic examples, you do a lot of common data validations, right? Like date formats, your currency formats and all of that. So ensure that you all do the validity checks and all of that. Now, all of these checks typically in a organization is done by looking at data within the organization. One of the key aspects that people also tend to miss is, can all of these validations be done through an external agency as well? Classic example today in India we do is Aadhaar. You put in your Aadhaar number, right? You don't validate it within your system. You actually send that data to the Aadhaar platform to validate it. Similarly, if you are dealing with financial data, right? If you want to ensure that that financial data is valid enough, maybe say from a credit card perspective, I want to send it to a credit bureau to ensure that they give me the right information rather than you validating it within your organization data that you have. So look at ways of how you can ensure that all of these quality crisis that you have can also be validated by third-party vendors. Yes, there is a cost associated with it, but at the end of the day, it helps you garner more insights and accurate insights from the data that you have. Who are the players involved, right? Let's meet the actors, right? The data engineer. The data engineer thinks he or she is only responsible for getting the data from the source to the target. Data quality is not my responsibility, or it's someone else's responsibility, right? That's at least that's what we are seeing over the last few years. Try to change that culture. The data engineer should be aware of what a data quality process looks like, what are some of the basic quality checks that he or she needs to incorporate into their entire pipelines. Now, the next actor that we look at is data analyst. What is the role of a data analyst? He or she should be responsible for doing exploratory work on the data that you have, right? Do some experimentation, come up with new business models of how data can be used to generate more insights. But what does he do, he or she do? He spends most of the time cleaning the data itself, whether it is data in Excel spreadsheets, whether it is data in the databases, whether it is in a lake house. So that's the time that he spends. And then your business leader always complains that the data is not right because I'm not able to see the value that I can get from the data itself, right? So these are the key players that you see when you build a data quality capability within your platform. Now, if you look at the evolution of data quality over the last, I would say 10 to 15 years, right? Maybe before 2010, right? It is the traditional data warehouses, right? Running either an Oracle SQL Server, you use pretty much your existing ETL tools, SSIS packages, or maybe Informatica Power Center and whatnot, right? So you do manual validations, you have spreadsheets, then it is always about reactive, right? It's not about being very proactive in nature, where you're able to catch an issue before it occurs, right? That was kind of the pre-2010. Now, what happened between 2010 to 2023? I think we improved a lot, right? We did a lot of automated ways of doing things, right? Automated testing came along the way. There were monitoring tools that help you catch some of these errors before it actually got escalated to senior leadership, right? And then the focus was always in terms of identifying the problem, right? Identifying the problem from a platform perspective, identifying the problem from a data perspective before it shoots up. You don't want your CFO talking in front of the press and giving some wrong numbers, right? Now, what does the future look like? Future looks like quality by design. Quality should be part of your decision making from an architectural perspective. Ensure that quality is there as a guiding principle. I think one of the speakers earlier talked about, I think under the design principles, governance and data quality. So ensure that data quality is part of your entire life cycle when you design your platform itself. Self-healing systems. What do I mean by self-healing systems? If a pipeline has certain data quality capabilities inbuilt, ensure that if the pipeline fails for some reason, it is able to self-heal on its own, right? You don't want to have a manual intervention or just operations people just sitting in front of a monitor to restart that process or a job, right? So you need to have intelligent self-healing in place so that the process restarts by itself, or what you hear is the next day the business users come and say, hey, the ETL failed, I'm not seeing the refreshed Power BI dashboard. Let it not happen, right? And the last aspect is prevention focused. How do you ensure that the issue that happened last night reoccurs again? So ensure that prevention is the best medicine so that you or your data team can focus on something else. Right, so this is kind of the evolution that we have seen over the last few years. Futuristic, there are a lot of technology tools out in the market that help you with a lot of these aspects, which are mostly AI driven. I know there is AI buzzword in all of the tools that you see today, but I have a slide that actually talks about what features that you need to look at from a technology perspective, right? So let's ensure that we use the word AI in the right possible manner. Just like Mr. Kumble being one of the finest cricketers in his, over the last 20 to 25 years, right? It did not happen over probably a year or so, right? He has practiced a lot. Every day he wanted to see some continuous improvement, right? In how he bowls, in how he fields, in how he bats, how he becomes a team player. Similarly, data quality cannot happen overnight. So you need to have a continuous improvement of your data quality journey. So this is kind of the maturity path that a typical organization looks at, right? Level 1, it's always firefighting, right? Where you see it's always reactive. Probably this, you might see a lot of these in very early stage organizations. More mature organizations might probably be in level 3 or level 4. But level 1 is probably where it could be a startup, it could be a fintech, it could be an organization that's been maybe a year old or something, right? It's always about reactive and trying to set up the processes. Level 2, there is certain amount of data quality. Maybe there are certain rules, basic rules that you do. Maybe you do a null check, you maybe do a format check here and there, like a typical data engineer's mind, right? Probably that's the level that you look at. Managed quality, this is where I feel a lot of organizations today are at, where they have a clear-cut automated way of detecting data quality issues, and they also have some delineation in terms of who is the clear owner of this, either the process or the data itself. So I think it's more of an organization that is getting to a mature state from a data management perspective. Level 4, optimized quality. This is the organization, it's probably where they have proactive measures, where they have architecture being considered from a capability perspective, and data quality is baked into that thought process, right? I think that is where you see a lot of organizations are going through. What happens with this is, one of the aspects that you talk about is also the business metrics, right? So when you design all of this, ensure that business is brought into the conversations. Let's not be an IT-driven organization where data quality is considered an IT aspect and not a business aspect, because ultimately it leads to business issues and wrong judgment. And then level 5, which is transformative quality, which I talked about, is organizations that are post 2024 onwards, where they have either self-healing systems or they are already using some kind of predictive mechanisms to predict that the data that I have, the processing that I have, I might foresee a problem 2 months from now, 10 months from now, a year from now, right? So they already are trying to look at those predictive capabilities. So I think from a maturity standpoint, organizations that are 3 and above should start looking at how do I get to level 5. I think that's where you will probably, I will not say that's where the buck stops, but at least you will be in a very matured state, and you can call yourself a data-driven organization. So what are some of the guiding principles from our data quality architecture, right? Validate at ingestion. Typically when you talk to people within an organization, they always talk about, I need to ensure that data quality is done at the source, right? What source are you talking about? Are you actually talking about the source of your business applications? Are you actually talking about the source from where you are ingesting the data, right? If you are doing a greenfield project and you are buying a new application or building a new application, yes, you can do data quality at the source. But when you're talking about organizations that have been there for 10 to 15 years, it's a mix of legacy and new applications, right? There's always a tendency to look at risk aspects if I'm going to touch a system that's built 15 years ago. So there's no point in going back and saying I implement data quality in those systems. Forget about that. That's not going to happen, right? So let's be very realistic. So at least in those scenarios, yes, one of the options that you have is when you ingest the data, let's ensure that it doesn't come into my platform. It doesn't at least reflect in bad judgment, right? So let's stop bad data coming into the door, at least from a data platform standpoint. Monitor in transit. So as I said, let's try to build self-healing systems. So it's not just about building an ETL pipeline where you have a source and a target and doing a data source mapping. That's not what we are looking at. You need to build self-healing systems where if your process fails, it has to have the restart capabilities from where the point of failure happened. And it also needs to ensure that data quality is baked into the framework itself, right? There are I have a slide that I'm talked in terms of a reference architecture as well. Data quality needs to be done at different phases of that journey in your ETL pipelines. It's not just about doing once and you're done, right? So classic example today, a lot of organizations follow the medallion architecture, and I will talk about it in a while. The next is maintaining lineage, right? So you need to know from where the data came from, who changed it, who are the users and all of that, right? So let's ensure that with good data quality also comes several other peripherals around it. One is data lineage. Your business wants to know, you as a data engineer would like to know where this data came from, right? From an architecture perspective, if you want to showcase what data landscape that you have to your business users, data lineage becomes very important. Alert and anomalies. Apart from data quality, today one of the core aspects or capability that people are looking at is called as data observability, right? It's not very close to data quality, but it is certain aspects of data quality itself, right? Data observability gives you the essence of doing analytics to detect anomalies. Assuming that, say, you have a dashboard that gives you sales revenues, right? Today you see a number of 10 million, maybe a week from now you see a number of 15 million, and maybe a month from now you see exponential 150 million, right? So you see an exponential increase of 10 times, right? You tend to see, was there something seasonal because that's why the revenue increased, or was there a problem? Right? So you need to be able to catch these anomalies, and data observability platforms today have those capabilities to do those analytics, right? So try to inculcate data observability as an aspect within your platform, and detection and notifying is by default, right? It is not an afterthought. It's not that you have data quality capability and then I will think about putting together alerts, notifications. No. It's a no. Let's have it right from day one. So what are the data quality architecture frameworks, right? Quality at the source. So as I said, validate at ingestion, right? The second aspect is there is a newer concept that's been talked about over the last couple of years, which is about data contracts, right? It's a fancy word, I would say. People have been doing this in the past. If you have done APIs and all of that, there is always a schema validation that you do. So data contracts are very similar. It's a structure to it, whether it is an XML, JSON. The only thing that has been added to these data contracts is more about defining your SLAs and all of that, right? So your service level agreements are baked into these data contracts, so that if you are consuming a data from another source, you need to ensure that the source is responsible if the data is in a bad condition, right? It's not the platform issue, it is someone else's issue, but that needs to be captured within your data contracts. So the data contract helps you with ensuring you build a structure in terms of how you ingest the data, because tomorrow if you have an attribute that's defined in a certain data in a certain format and someone changes it to another format, you need to ensure that it's recorded, right? And these data contracts will help you with that. And then the source assessment. Let's ensure that you do a right assessment of your sources, and I will talk about what kind of assessments that you can do. End-to-end observability, I talked about it from a data observability standpoint. These anomaly detecting tools help you with that. Metadata management, crucial from a data quality standpoint. If you want to have good data quality, you need to have a foundational metadata layer, right? So the metadata layer will help you with running data quality checks. It helps you with doing a lot of automations. It helps you with doing a lot of automations baked into your DevOps pipelines as well. Quality metrics, as I said, quality metrics needs to be part of your data quality framework, because at the end of the day, someone wants to see what my data quality metrics look like. I want to understand what my accuracy level is. I want to know what my validity levels are and all of that, right? So you need to have good metrics around it. Automated enforcement. Let's ensure that this is at an advanced stage, where if you are in level 4 or level 5, as part of your DevOps culture, also ensure that you inculcate data quality testing as part of your DevOps. Today, a lot of tools can integrate with SonarQube and all of those. Let's ensure that you integrate with those, right? From a quality code perspective, you're doing quality testing of your code. Let's also do quality testing of your data as well, right? So there are a lot of frameworks available to do that. That's where the quality gates come in. Quality culture, right? So most important is, if you don't have that culture, nothing works, right? If you always start complaining that I don't have this, I don't have that, nothing will work. So define a clear ownership, define clear SLAs in terms of how you want to measure data quality from an organization perspective, and then the business metrics will follow that. If you have this culture, you have a good defined metrics coming out of your platform itself. And this is kind of the reference architecture that I typically will give to any organization, which typically follows a medallion architecture that you probably are all familiar with, right? So you have the bronze, silver, gold, you have the source systems. So when data moves from your bronze to silver, you need to have one data quality check being done, right? That's the first gate to understand how the data in the sources are, right? So you capture your data quality metrics, and then when data moves from silver to your gold layer, that's where your standardization happens. You do the enrichment, you do a lot of these external checks if you would like to, right? And then you have the data in your aggregated layer, which is your gold. So I would recommend you do a data quality check there as well to understand how the data looks after your enrichment, right? And then once you have both of that, then you have a data quality dashboard that gives you a before image of how the data was in my source, and then an after image of how the data was processed from silver to my gold layer, right? So I think my experience has always been that I followed this. It has worked pretty well. One of the aspects is it's giving dashboard is one thing, and then making it actionable is another aspect, right? So from a senior leadership perspective, what I have seen is there has to be some KPIs attached to everyone's performance over the year, right? From a data engineer perspective, I need to ensure that I have a KPI for the data engineer to say, I have 10% of your performance management for building a pipeline with data quality capabilities. From an executive perspective, I need to say I will have 10% as your performance guideline to say you mature my data by X percentage in the next 6 to 12 months. Without having that, none of this is going to work. So you need to have performance metrics or performance evaluation based on some of these data capabilities, and that is something that the leadership should thrive in any organization. How do you implement your data quality? Look at the technology stack. I know I'm running out of time, I have a minute. You need to look at the technology stack, look at it from whether the stack has a testing framework, does it have a monitoring tool, does it look at metadata management from a catalog perspective, does it integrate with CI/CD, does it respond to incident management, because that's how you integrate within the organization. When there are data quality issues, an incident is raised, right? So does it integrate with, say, ServiceNow, does it integrate with Jira? Team structure, very important. Do you have anyone that is very dedicated to managing data quality? Do you have a data quality analyst or an analyst that plays that role, or a shared responsibility with the business, right? And then the metrics. What metrics do you capture today? Does these, so I think having all of this from an implementation perspective, I think gives you an overall good structure to start from where you are. From a feature perspective, look at does the product help you with doing data profiling? Does it help you with defining data quality rules? And then does it give you at least a bare minimum data quality dashboard, right? So, and then I have noted for each of it what is it that you want to look at. But I think profiling is one key aspect. So what is next? Just give me 1 minute to finish this slide. So the next step from a quality excellence perspective, you do an assessment, right? What do you mean by assessment? When you do an assessment of your data landscape, one of the key aspects is do a data profile. The data profile will give you how the data looks like today. I'm not talking about doing a data profiling at your entire data landscape, but at least do for 10% of your critical data elements that is considered as a business KPI, right? So do data assessment. Your architecture should be well thought about, because quality should be part of your architecture. Implement it, what the architecture proposes, right? You look at the best of tools. There are enterprise grade tools, there are open source tools, there are semi-open source tools, right? So there are a lot of tools out in the market, and then start measuring your impact of quality improvements over a period of time. My experience, it takes good 12 to 18 months to get to level 1 to level 3. That's at least what I have seen in a medium to large organization. Smaller organizations, it could be faster. That's it. Thank you.
Thank you so much, Mr. Ram, for the wonderful session. Well, ladies and gentlemen, with this we come to the end of today's sessions. And thank you so much for staying here until the end. We can now proceed to the main hall for the session with Mr. Anil and the award ceremony.
10 to 15.
I think that to me is the biggest, proudest feeling that you can get when you go out there representing your country, and you're representing so many people, and you know that a lot of people want the team to do really well, want you to do really well, and that's a great thing to have when you're walking in to your own profession, when there are so many people backing you to go out there and do well.
Is it okay for me to ask you if you have a loyalty in the IPL at all?
No, I'm a commentator. You're a broadcaster too, Navneet. You can't. You need to be neutral. And yeah, I've represented 3 teams. Of course, I played for RCB. I was mentor for RCB for the first